Good morning, everybody. Let me just turn this off and make sure it stays streaming. Yeah, we're good. Cool. What do I want here? That one. Okay. We have a stream chat. Guess what we bought today? Well, if you read the title, you know, but we bought a Tenstorrent E350. You guys, good thing you subscribed to my stream. That's how we afforded the $800 to buy this. It was $800, and it's not going to deliver us $800 of value. We already know that. But, you know, we bought it to support the cause. We're drinking Highball Energy. This is like, these are discontinued, and it tastes discontinued, and that's like not a good thing. But we're still drinking Highball Energy. We got a Tenstorrent E350. It comes with a blower duct assembly, and we're gonna try to put it in the computer, and we're gonna see if that works. And I don't know, man, might work, might not work, but we're doing it live right here on George Hotz stream. Look, I know I haven't streamed in a while. Look, a lot of shit's been happening in my life, man. No, that's not really true. Nothing's been happening except for shipping tiny boxes. You know, I've been putting in a lot of work to deliver tiny boxes to the people. Is the voice low? Oh yeah, the voice is kind of low. Let me crank that. Crank that. All right, is that good? You can probably go in here and crank it more. Sound. Crank that. Oh, we are on the wrong microphone. Are we on the wrong microphone? I don't know. Properties. Yeti X. Alright, well that's what you got. So that's the voice. Yeah, we got lots of tiny boxes. We could just like go over here and you could like check out Tiny 12. So this is Tiny 12. It's a tiny box. I can show you look at this, boys. Oh, you can't see any of that. Look at this. Look at this communications matrix. Bidirectional copy peak bandwidth. Been talking to AT&T again. Sorry, not AT&T. AT&T genuinely are some of the worst people in the world. I'm talking about AMD, who's actually pretty nice. You know what? I will say this about AMD. They are a live company. Lisa Su is alive, right? Sundar Pichai, dead. Jensen, alive. Lisa, alive, right? Like you could just tell quickly interacting with a company. Qualcomm, I don't even know who the fucking Qualcomm CEO is. I've emailed him 10 times. Does he reply to me? No. You know, you're a dead company, bro, and it's sad. Qualcomm's real sad. But don't get me started on Qualcomm again. I believe, like, AMD can own the future. I'm very bullish if they go through with what they said they're going to go through with, but I've seen a lot of positive steps. And that's why the tiny box has 6 AMD GPUs in it. These are AMD GPUs. So you know we're bullish on AMD, medium on Qualcomm. I mean, look, they make a great chip, but they suck, and we are so bearish on AT&T, and like it's just, you know, AT&T is Boeing tier, boys, Boeing tier. But we're not here to talk about any of those companies here today. We're here to talk about Tenstorrent. So Tenstorrent has been taken over by one Jim Keller, the most famous computer architect, living computer architect. He created like the AMD 64, the Apple M chips, or the predecessor to the Apple M chips. The Tesla FSD chip, and now he's at Tenstorrent. So, you know, we like to support the cause. He also open sourced a lot of code, so, you know, we that's who we support, right? If you want to be like Cerebus, look, I like Cerebus too, but they haven't open sourced anything. So when Cerebus agrees to be open source and sell me a wafer that comes in a box, that'd be cool. No, they didn't ship me a card. Whoa, I don't fuck with that kind of shit, man. If it's like, we have one special card for you, I'm like, nah, fuck off. Anyone who wants can buy a Tenstorrent card right here. Just click add to cart. They'll ship it to you, right? You think I would not spend a minute of this stream if this was something special that I had that you couldn't buy? You can spend your own $800 and buy one of these. Not in the M series, but the A4, of course he was. I saw the truffle. Like, look, things like that, it's an overpriced appliance, right? You're much better off for the same dollars buying a gaming PC. But if you don't feel comfortable, if you don't feel comfortable installing your own Linux, maybe Truffle will be good. But it's an appliance. It's not. It's as dumb as like the rabbit thing. Like, don't buy these things, right? What you get sold is like, oh, you know what it is? You ever see? There's a great YouTube thing that tears apart MMORPGs, and people will buy into like MMORPG pre-orders because they want to be part of a community. And they think that the MMORPG is going to somehow improve their life. And I really regret, like, there's a lot of people who saw my Lex and thought, like, the tinybox was going to be, like, a personal firewall for your house. Like, it's not. It's not, okay? The comma is not a self-driving car. It's a driver assistance system. And the tinybox is not a firewall for your house. It's a budget AI training computer. It's just about the best flops you can buy per dollar. But if you don't understand what flops are, the tinybox is not for you. No, the tinybox. Oh, the truffle? Dude, the truffle. Don't even. Dude, I'm not even going to go into it, okay? It's literally the NVIDIA Orin in a plastic case, okay? Like, is there anything else with similar RAM and bandwidth for that price? So, yeah, it's, I mean, okay, you like the high RAM, right? Yeah. I'll show you. If you guys don't know about, right, like, these are the orin dev kits. I don't know why you can't type orin. How much RAM does it have? Which one is it? It's one of these. Wait, it has 64? Alright, fine. We'll look at the truffle. Because, alright, fine. Truffle, AI, computer, shit. NVIDIA Orin GPU. Huh. Okay, maybe it's actually a better deal than the NVIDIA one. I take it back. If that's actually what it competes with. How much is this? Okay, never mind. Nvidia's scamming is too high. So yeah. No, but if you're looking for how much RAM bandwidth does it have? 200 gigabytes per second. I mean, this is on par with an AMD EPYC. I don't know how they're getting that price. Okay, it's less of a scam than I thought. I thought it was just a plastic case around something that cost like $7.99, but I didn't realize how much NVIDIA was scamming, so whatever. What? Like how? Alright. But yeah, like you might have a good experience with this. If you're the kind of person who likes Olama, you might like Truffle. Like, this isn't what tinybox is at all. But I think that what happens, like, with a lot of devices like that is, like, you buy one and, like you think you're going to use it, but you don't. You're much better off at that price point. It's true you're not going to get 64 gigs of RAM, but you're much better off at that price point buying a gaming GPU. I don't know, but I guess if people want the high RAM for LLMs, I mean, it's an interesting. LLMs are interesting like that, where like it's not really the flops matter a lot less than the RAM bandwidth. Of course, you've seen our specs. 5.76 terabytes per second. Now, to be fair, that's not full fabric, right? So that's each GPU has, I just added the RAM balance up, and you can access things that fast, but you can't access anything that fast, so that's just how RAM works. GDDR7 coming in hot, let's go. Wait, so I was talking last night, and I heard that there just might not be 5090s, right? Think about it. You're NVIDIA, and you have two products. One that makes 30% margins and sells to gamers who you got to deal with, versus the other that makes 90% margins and sells to corporate-ass people. Like, which one are you going to manufacture? If you have limited capacity on your line, which TSMC does, are you going to manufacture the 5090 or are you going to make more H100s? Yeah, we are trying to push AMD. I had another phone call with them yesterday. Look, like, again, they're a big company. You have to give them some allowance for that. But they, like, you know, they're trying, and they're not like they're trying well. They're not like, I don't mean it like they're trying like, oh, they're trying. I mean it like they're trying. You know, they obviously don't want there to be bugs in the driver either, and I think we can get to a better place together. Yeah, if they embrace open source, they'll take the lead completely. The idea that these companies don't embrace open source for some reason, it's like a backwards way of thinking. And I don't mean this, again, I don't mean this in like a progressive shaming. Like, that's a backwards way of thinking. How could you say that there should be slavery? You know. I don't know, man. You know, you gotta think of the pros and cons, right? That's why we gotta make machine slaves. And that brings us to our stream today, which is the Tenstorrent E350. Let's open the box. All right, so I'm gonna nudge this down a little bit, and you're gonna watch me on the floor trying to plug this into the computer. Okay, it comes in a white box. They list on the back their patents, week. What's in the box? Let's see what's in the box. Okay, comes with this little card. It comes with some stickers. All right, little envelope-y thing here. Little envelope-y thing, some stickers. All right. Comes with a piece of. Let's make this a real unboxing video. Comes with a piece of foam. And then in the box, we have a Tenstorrent card. All right, what do we think? It has a hole for a Tenstorrent card. Sorry, that wasn't very ASMR of me. Look at this Tenstorrent card. But you know, we're bullish on AMD, and there's going to be an announcement. They told me there's going to be an announcement in a week or two. You guys will see. We're bullish on AMD. We'll see if they actually come through with the announcement. But for the most part, when they say they're going to do something, they do it, which you know, I can respect. They're not liars. They're not liars, and I'll say this too. In all my interactions with them, sometimes I'll interact with people, and they lie. They lie because, like, I haven't found that at all with them. They've been straightforward about everything. You know, again, everyone's not going to do exactly what you want all the time. Yeah, they you know, that's when someone starts lying to me, that's when I get very upset. When you start here, like, you know, I could talk about some interactions with some companies where they're just liars. And I'll tell you about lying too. Here's the thing about lying. When someone lies to you, they're lying to themselves. You can't just lie to other people. If you're a liar, if you're someone who frequently lies, you no longer have a coherent world model. You no longer have, you know, what it's the old saying. It's like it's so much easier to keep the facts straight if you just tell the truth, right? Yeah. So they lie to themselves. The organization, when a salesperson lies to you, the whole organization's just full of lies. And I haven't found out with Andy. Here we go, and here's a Tenstorrent Mega Blower Fan. Okay. Did it come with screws? How do I stick this on here? This is also not going to fit in my computer. Wait, what the hell? Did I misunderstand something? Are there screws? How do I stick this on here? Like, I see what it's supposed to do. Oh, there's screws. Hang on. Put this camera back down. All right, full screen guy. Okay, so we have our Tenstorrent card. And we have a blower fan, duct thing. And in here we have some screws. But wait, is this going to fit in my computer if I put that thing on the back? And I see what it's supposed to do. How am I supposed to screw that in, though? There's no way this is going to fit in my computer. Okay, let's unplug my computer. We have Q over here. It's a normal gaming shit computer. I mean, maybe it'll fit. I'll move back a little so you guys can see. I clean my room just for you and for Jordan Peterson. Is this gonna fit? Okay, so that's that long. And this guy gonna go back here. And there's no way in hell that's gonna fit inside my computer. God damn it! Look at this thing! Did Tenstorrent think about this? What am I supposed to do? We could go fanless. Alright, well, let's take out. I have an old AMD card in here that we're going to take out. Oh, I need a screwdriver too. Where's the screwdriver? Maybe there's one in this closet. Screwdriver. Oh no. You told me I don't have a screwdriver. We did not prepare, boys. We did not prepare. Did you want me to prepare before the stream? Is that what you wanted? You know, the little IKEA tool chest here. You know them IKEAs? I'm about to blow a bag at IKEA. You just want the content. I know, yeah, you didn't want me to prepare before the stream. That would have been lame. What do you prepare for? Oh, and of course I gotta figure out how to push that damn PCI thing. I need a poker. Or it'll hurt my hand doing this. It'll hurt my hand. There we go. Oh, well, we broke it. we're taking out the red devil. This is an RDNA 2 card. Disgusting. No, we love AMD, guys. We're AMD fans on this channel. Who are we not fans of? AT&T and Boeing and the deep state. Watched a good video about the deep state last night. All right. So is there any way this is going to fit? Maybe. Maybe it will. Just barely. How do I put this on? It came with screws, but like, am I an idiot? Let's go back to the tape. Oh no, and it feels like this fan doesn't have any speed control, so it's just going to be loud. So we have a blower, we have a card, and it came with 3 screws. But how do I put the screws in here? Oh, I probably have to take this apart. Okay. So of course, I don't have the screw head. We're gonna have to find more screwdrivers. I know I have more screwdrivers, I just don't know where. I have like one of those like kits for mobile phone disassembly somewhere. But I don't know where. In here. I have a vape in here. That's pretty cool. No. No look. Some hex things in here, but no, it's not going to be any of these. We have to take these screws out. Maybe we can use pliers? Do it carefully. To get the right screwdriver. But also, is this just going to be loud? Let's first check. Let's just first do a loud check. Because if it's going to be loud, I don't even want it. This computer's name is literally quiet. So, you know, loud is kind of the opposite of what it is. All right. So let's take this weird fan assembly. Let's plug it into some power here. Let's turn the computer off. How loud is it going to be, boys? Loud as fuck! Oh wow, it's a lot of air though. Alright. We're making an executive decision. We're going fanless. How hot will the card get? I don't know. Let's go fanless. Let's find out. Tenstorrent, I hope you wrote good thermal protection. I can see the press release on their website. George used the card outside of its normal specification. He thought the fan was loud and didn't put it on. It is loud, okay? I didn't think it. That's a fact. No. We're here to like Tenstorrent. Jim's cool. He does the right thing. We're going to go through the quality of their software in a bit. But so far, I don't know why he didn't think of this fan being used in residential environments where I'd rather not hear something that is stupidly loud. So the blower duct assembly is going back from whence it came. All right, we're back to the card. Let me go over this for you. Let's put the card in the computer. Let's get this thing powered on, and let's get this show on on the proverbial road. The card's rated for 200 watts, so I wonder what it is at idle. It has a big heat sink. It's not like it's going to overheat immediately. Get in the hole. Doesn't want to fit. Okay, the fan assembly was not user-friendly. This card was clearly not designed to go in normal people computers. 0.1 for GPUs. Alright, got it in the hole. Let's put some screws in it. I don't know what a Tenstorrent E350 is either. We just bought e150 is either. We just bought it for $800 using profits from this stream. So I hope you all appreciate. You know what? I probably should have plugged this wire in before I stuck that in the hole. We have a 6-pin connector and an 8-pin connector. Now they're both connected to my power supply. Fits in nicely with my 3080 Ti. Let's put a saw for my piece of tempered glass back on here. Do you think it overheats right away? I think it's one of these cards that has no thermal management and it just like it throws the 200 watts constantly. The blower fan assembly was not well thought through. I think it should have speed control. Actually, I gave this feedback to Tenstorrent while I was visiting. I saw the thing and I'm like, oh really? It's an external fan? And then they shipped it with an external fan. So yeah. It didn't get better. I had this problem once with the, I bought one of them Xeon Phi cards that was meant for data centers. Okay, the E150 is inside of the computer. Let's plug the computer back in. We got power, we got network, and we don't need anything else. Let's go. Just put my tools away. Let's do what the card says here. We'll go to tenstorrent.com/setup. I remember early on they wanted to give give me early access to a Tenstorrent card, and they were like, "You have to sign an NDA," and I was like, "Nope, not doing that," because if you sign an NDA, you can never give your real opinion about things. My opinion so far is that the fan is too loud and too big. I'm on stream. Also, the fan is too loud and too big, and I put the Tenstorrent card on my computer without a fan.
Oh, I thought you were just talking to yourself.
Alex? 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 Why do you say anything like that? Domestic violence time. What kind of household do you live in, man? I'm sorry, you come from a broken home. Okay, so LSPCI. Where's my Tenstorrent card? Ooh, here we go. Processing accelerators. All right, let's get to work. Setup. It would be nice if I knew if it was overheating or not. I can touch it. Doesn't feel hot. We're good. Let's see what the hardware installation says about the... Oh, guys, we didn't use an ESD wrist strap. All right. tt-KMD. This is their kernel driver. Let's check out their desired version of it. We'll add it to DKMS. Great, that's pretty easy. Let's install it. All right, Monpro Tenstorrent. Great. Let's see if it's cool. We can also do update PCI IDs. There's a chance that they added it. Nope. Oh, here. Processing accelerators. Tenstorrent Grayskull. Great. They added it to LSPCI. Okay. Let's update the firmware. Is any issues installing tt-flash? Detected wormhole. Be skeptical. Good. We have a Grayskull. Okay, cool. Firmware. Is the firmware open source? No, the firmware is not open source. It should be. Why is the firmware not open source? Oh wait, no, also tt-flash didn't install. Cargo, the Rust package manager is not installed. Great. George, you didn't use Rust up. You're supposed to use Rust up to install Rust. I haven't apt updated it in a while. Let's take a look at this. What? Banjo.canonical.com? Why isn't that working? Why do I have Banjo? Where's Banjo coming from? Why does my computer have a Banjo? What is Banjo? Oh, creepy. Now we'll have cargo, and look, now it's installing LVM17. We've moved up in the world. Oh, I can disable this. Great, good. Fuck off, data collection. Don't connect to Banjo. Still connecting to Banjo. We don't mind as long as you use Rust sometime in the future. No Rust. Alright, we have to wait while cargo installs so we can install tt-flash. While we wait, let's take a look at the firmware. Wait, what? 404 not found? Uh-oh, we're not off to a good start here. Your firmware install link's broken. Fortunately, I know about GitHub, but if I was a grandma who purchased a Tenstorrent card, I would be in for a rough time. Where are the releases? / releases. Okay, there are no releases. So why does it think there's a release? Here, we can get 4.0, or here we have new versions. Do we want new versions? Do we want to download 4.0? No. I don't know. That one seems pretty good. We might not even need to update the firmware. The firmware might be okay. So we'll notice that's not the latest one. This one's actually newer. Release patches. Workaround to address TT metal issue. This sucks. Why is this firmware not open source, Jim? Open source your firmware. Great, not in GZIP format, because that's not a real link. Is that a real link? Great. That is so rude. That's so rude. You didn't put it in a... No. No. You didn't put it in a thing, and now I have to do this. Oh, rude. It's just rude to not put your thing in a directory, you know? Okay. Wait, we don't even have my card. My card's not even in here. I have an E... Does this one have it? Why don't... Where's my E... I have to reboot the computer? Alright, let's try reinstalling tt-flash. Now that I've installed Cargo. But wait, I don't understand. I have an E150. Where's the E150? Where's the E150? Perhaps the same? You're telling me I have to use the crappy tiny firmware? Alright, let's try again. tt-flash, firmware tar, firmware pack. Looks like you're running a very old set of firmware. It's safe to assume that it needs an update, but you should update it using force. That's very sketchy. Also, it's very sketchy that this download didn't work. Okay, let's try this one. It says an error that the firmware is too old. You should force it. Alright. This is so sketchy. I think I just broke my card. Let's give it a try. Okay, we're verifying the flash. Flash complete. Power cycle the board. A host reboot will usually accomplish this. Alright. bedroom or my workroom, bros, work-life balance is a scam made up by people who don't want to work hard. And if you don't want to work hard, you should have, you know, whatever. I don't know. Like, this is why I can't stream anymore. Like, I'm sick of saying that kind of shit.
I'm sorry.
Thank you. Enjoy yoga. Now, Jim, the fan is too loud and too big. Alright, good. Is that Trinity? Yes. Alright, come on back, Q. If you don't want to work hard, you get UBI. I heard you can go to Switzerland and kill yourself. Legally. It's like a nice experience, I've heard. Alright, let's install tt-smi. Oh, wait, do we have the module installed or do we have the mod pro again? We have the module, okay. Alright, it's downloading 17 other things. Great, love it. tt-smi. Ooh, that's pretty nice. Alright, ooh, this is nice. Ooh, good work, good work. Wow, I wish nvidia SMI was this good. NVIDIA's got to step up their game. That's pretty nice. That's the nicest SMI I've seen. Good thing we trained our DRAM. Good, good, good. We only have a little bit of link because we're in a crappy computer, but that should be okay. Now, unfortunately, it doesn't show me a key thing I care about, which is the temperature of the device. Core temperature. Okay, okay. Wow, that's updating very fast. Good. We're only drawing 9 watts. Okay, that'll cool passively for a bit. Wow, this is the best SMI I've seen. Good work. Yeah, but NVTop's like a third party. No, I had put the device in. You didn't watch the beginning of the stream. Alright. Okay, getting started with tt-buda and tt-metalo. Alright, let's start with tt-buda. tt-buda demos are in a different repo. I think they have bounties too. Should we try to claim one of their bounties? Look here, there's bounties. I am working on this. No. Don't. Look. Advice for people doing bounties. Never trust anyone who says crap like that. Sorry to pick on this guy. All right. He does have a greenish GitHub. Maybe he'll do okay. But still. Until you see a pull request from people. All right, what's Quen 1.5? Oh, I have to include a comprehensive README? Ugh, how much do I get paid for this? $500? That's not worth it. I will submit a pull request though. How comprehensive does this README have to be? But wait, let's see if we can claim enough bounties to pay for our thingy. Can you link this issue using the Algoria source open? No, stop pushing your token shit. All right, let's go. Well, let's clone the demos repo and see if we can get a demo working. Do they have a MNIST, for example? We were joking yesterday that MNIST isn't going to work, but we are going to get it to add 2 plus 2. First 5 steps. Install tt-buda. Okay, let's go look at that here. Why is this in the demos? Set up huge pages, eh? Docker or virtual env. I hate both of those things. Stop you know the joke about Docker? Look, man, it works on my computer. Oh, well, yeah, but like, how are you gonna package it up to like ship to other people's computers? I don't know, man. You want to just like make a tarball out of my computer and then we can ship it to people? Docker. All right. Wow, no. But like, I love this SMI, and everyone else needs to step up their SMI game. Wait, it says Buda's installed even. No, wait. That's not the right. I installed different firmware. Why does it think that that's the firmware version? Why is this different? I don't know. Ooh, I can get ETH firmware. But does it have token? Okay, install py-buda. Oh, they use TVM. That's smart. TVM is a tinygrad competitor. It's pretty good. All right. I don't want to do Docker. I hate Docker. All right. Huge pages. Yeah, huge pages are fine. Home devices 1. Ooh, editing the grub. Sketchy. Update grub. Wait, what? They mounted it in. You can just do that? It's an SCF stab now? That's cool. Alright, we can reboot later. Should we apt-get upgrade no install recommends? We're connecting to Banjo again. I'm really sick of Banjo. py-buda compile. What is all this crap? I don't really want any of that. Torch vision. Smoke tests. No py-buda. Can I build it? You've downloaded the latest wheel files. Just download a wheel? Let's just download some wheels. Oh, Python 3.8, that's disgusting. Probably only works with this one though, so let's try it. Not a supported wheel on this platform. Okay, well. Wow, that's a large wheel. We have to keep an eye on the temperature. 46. Oh, great. We have to install TensorFlow. Block Banjo and Etsy host? That's not the worst idea. Someday I'll convert to Arch and have to worry about so much more crap. Let's let it install stuff, and while we let it install stuff, let's check out Metalo. wrapper to convert to py-buda first. Where's the metalum one? Okay, that's pretty cool. GitHub project is located here. Why is it in a separate organization? See if this has tons of weird instruction guides. If you just came from building from source, installation instructions, okay. A note about rebooting. Oh, the minimum number of reboots will be 2. I don't even know about that. Good thing we didn't harvest it. At least one unharvested? How do I harvest it? Oh, wow, okay, they had a helpful Python script to enable huge pages. Okay, we're gonna install some stuff. Let's see if the smoke test works. Great. Okay, which of the instructions did I not follow? I have to install a new boost. Boost. Docs. Let's let it update all this crap. I regret this already. Should we tell the banjo to fuck off? Yeah, let's tell the banjo to fuck off. Yeah, no banjo for you. It's gonna take a long time. I don't want to wait for that. Do this. Okay, a comment to remember why I did that for later. Hey, they're actually selling cards based, right? No, the cloud is a scam, guys. The cloud is dude, like someone told you that the cloud exists. The cloud doesn't really exist. It's one computer. Haven't you seen that? That's the cloud, right? All right, let's try the smoke test again. Oh, well, we need libyaml cpp. Okay, well, we'll do a few more of these installs. Where's YAML? None of these even are YAML. Oh, here we go, that one. Those seem like inoffensive dependencies. Some dependencies are offensive. Gotta have YAML. Alright, well, we don't have libzmq. Okay, well. Have they considered tinygrad, which doesn't have dependencies? What's a dot file? I don't even know, man. Is there a way to do this faster? Could someone else do this faster than me? Am I an old man? Sometimes I feel like an old man. And now we're up to this kind of crap. Undefined symbol. Tensor impl compute stride-like channel identity. Okay, this literally has... Alright. Well... Tensor impl compute strides line. Let's see what this is in. It's in like PyTorch. Like the wheels should have fixed this. Has the wrong version of PyTorch, probably. The Metalum has a better way of checking the huge pages thing. Let's just do this. Where's set up huge pages? Should we reboot? Even though that's totally not what's causing the torch problem. The torch problem is other crap. Still the second pass of the huge. Oh, well, I have to recurse submodules. Also periodically check LFS. This is so complicated. Observe max tensor slots in bidirectional. This is why tinygrad's gonna win. You can follow all this stuff. This is why tinygrad's gonna win. Like, look, I'm pretty good at computers. I just tried for forever to get this set up, and there's some problem with, you know, what, oh, I love how fast the computer reboots. Oh, these desktop computers reboot so fast. Okay. So I probably have the wrong version of PyTorch. Alright, it seems like I have some old CUDA version of PyTorch. Should we update PyTorch? No, Nix is no. No, I don't want to talk about Nix, okay? I tried Nix once and it was more confusing than all of this. No, but Nix is really beautiful. Yes, I understand it's really beautiful, but once they figure out how to express it beautifully and not just have beautiful ideas, then Nix can take off. But until then, it won't. Yes, the idea of, oh, it's all version control, yes, that's beautiful. Docker is absolute trash and still wins because it's kind of paying costs millions. Yeah, let me show you a real way to solve this problem, okay? All Docker does is layer tons more crap complexity on top of things. The real way you solve this problem is you don't have fucking dependencies, right? Those are tinygrad's dependencies. Like, stop writing code that includes the world. But no, we just need this. We need this. Look at this package. It returns yes. It returns the word yes. I can't write a function to do that. Like, no. But you have to use libraries in order to make your code maintainable. No. Like, this is tinygrad's thing. Like, yeah, we link to some libraries using this autogen stubs, right? We have a few C types autogen stubs. They're really easy to regenerate. Everybody needs to stop with all the dependencies. And you know what it is? It's so mediocre software engineers can have jobs. Like, I'm really convinced that most code in the world exists to give mediocre software engineers jobs. All right, is it gonna work now? Let's see if it works. No, same problem. Wait, is that a different error now? Compute channels last 2D dim? Wasn't it 3D dim before? I feel like it was 3D dim before. Right, there's probably an exact version of PyTorch I have to use for this. Maybe I should try to build this from source. And not use a wheel. Do I have to use, oh, if I have to use Docker, no, I refuse to use Docker. Okay, well, first let's see if our huge pages actually worked. Oh, sweet, we have huge pages, great. I didn't have to do 2 reboots. Torch Vision install, where is Torch? Oh, that's Torch Vision, I don't think that matters. Let's try building this from source. Oh, we have to like clone all the garbage. What is it? Like a way to do this with like submodules. Yes, let's make the world a submodule, yes. But no, this is exactly, right here is why, everybody who has shit like this, like, I'm buying NVIDIA. Wait, actually, let's buy NVIDIA. Oh, look at NVIDIA. Wow, look, it worked. It even updated the driver. Let's use NVIDIA. Oh, import Torch. Wow, look, Torch works. All right, let's, I don't know, let's like make like a random thing on a CUDA device, right? Wow, look, that just worked. Oh, let's multiply those 2 matrices. Oh, look at that, and it's on device CUDA 0. Notice how it didn't give me any errors, right? And I didn't do anything special. I just pip installed Torch. That is the incredibly valuable thing that NVIDIA has. And until every company understands this, like, no one's going to seriously compete with NVIDIA. I press this, like, I tell AMD the same shit. It's like you need reproducible builds. You need to get rid of most of this crap, because that is what gives NVIDIA, that's what lets NVIDIA charge 90% margins for shit. The fact that it just works. Now, there's 2 ways to make things just work. Right? You can make things just work by managing insane amounts of complexity. This is like the Google approach, right? You can get really good at managing large amounts of complexity, or you can also just not have the complexity to begin with. Any computer you can go to, pip install tinygrad, and it will work. Oh, and then people think AI is going to fix this. Oh, don't worry, AI is just going to be another shit layer. Well, now I don't use Docker directly. Now I just have AI spin up my Docker and my Kubernetes. Like, no, you guys are. This is the reason all software is shit. No, Zluda is. This is exactly not the answer. Even HIP isn't the answer. tinygrad doesn't use HIP anymore. We use HSA. It's 1 level lower than HIP. Stop putting crappy APIs on top of other crappy APIs, because I'll tell you about crappy APIs, right? Like, if you have a crappy API at this layer, and then you build another crappy API on top of it, now all you did was crappy times 2, right? This crappy API didn't fix this underlying crappy API. It just added its own crappiness. It's pretty competitive on AMD now. Yeah, it's just pretty similar to Torch. If you beam. Well, it's not crappy squared. Maybe it even is somewhat. There is a squared component to the crappiness, too. All right, undefined symbol, tensor impl, compute channels 2D last. Okay, let's figure out exactly, maybe in requirements, it'll tell me which version of Torch I'm supposed to install. Python and requirements. Okay, so Torch here. Okay, here we go. It has to be this one. Oops. Yeah, Devin. Yeah, great. Okay, let's see. Does that fix the problem? No. Nope, now we have a new problem. let's try installing all the requirements. Install -r python env requirements. I don't understand why the wheel didn't do this for me. Oh no, now this is a newer version. Nope, this is gonna break. Torch library kind optional dispatch key. Great, and that doesn't even work. Oh, well. Let's try. Did I try this already? What did I get when I did that? Oh yeah, I have to do git submodule. No, it's not that like all software is not crap. It's just like the complexity. This is not the way to deal with complexity. Like you know, you want to see some great software? Redis. This shit's great software. You know how many lines Redis is? Like this is great software. Here, let's go into source. Look, it doesn't have multiple layers of directories. It's just this. You can just read it. Simple code, and it works incredibly well, and it like powers the whole internet. Like that's a great repo. And here, just to play. Let's build Redis. Okay, so I go to Redis and I type make. Wow, is this gonna work? Is this just gonna work? Because this software is not shit? I could have thrown some J's on that bitch, but no, we can make fun of Redis if this doesn't work. Actually, let's throw a J on that bitch because it's taking forever. Oh. Okay, so we're missing J.E. Malik. Look, they even tell you about this. Let's use libc's Malik with a J. Oh, libhdr histogram. Okay, okay. All right, never mind. Redis has too many. Why does Redis depend on a histogram? Why? Why? After a reboot. Never mind. All software is shit. Oh, wait. Hang on. No. Okay, it's a little bit unfair because I think it was building. What? No, I just want the server. I don't want the test. I don't care about the test. Oh, okay. I don't know what I did wrong, but it worked. Okay, that's pretty good, actually. That was kind of fine. That was kind of my fault. I didn't specify what I was trying to build. But there we go. Now we're connected to Redis. Maybe we should also build a client. That might have been my fault because I stopped the build or something. Well, let's not blame Redis. That's a pepcac error. Maybe it'll just completely build.
There we go. Beautiful. That was a petcac error. Now I'm connected. Ooh, let's do help. All I'm saying is Redis is good software. Alright, good. We've initted the submodules. Now let's pip setup install. Oh, key error. Backend arch name, of course. Of course we're going to need to give it a backend arch name. Okay, well, let's see what we have to put in for that. Here we go, Buda backend. Okay. Arch name equals, we have a Grayskull. Backend arch name. All right, looks pretty good. How many lines in Redis? Oh, let's take a look. Kind of a lot, but I bet a lot of them aren't needed. 100,000 lines in Redis. How much of these are like? No, wait, no, there's actually 100,000 lines in Redis. All right. That's not crazy. It's also written in C. What else is good code? Let's try to build MySQL. Is MySQL good code? Yeah, that's a fan. It's building. Oh, we don't have B-dot yet. Yeah, it's throttling my poor little Ryzen CPU there. SQLite. Well, SQLite's just even a library. It's not even a... SQLite is good software. SQLite's phenomenal software. I think it's just a library, though. I don't think it's anything else. Well, this is a little bit large. I will say this is a little bit large. And why does SQLite not have CI? Do we think this building is going to work? All right, let's play with tt-metal. Maybe tt-metal works. Installing. Oh, good. That's the one we have. Great. Let's go to tt-metal. What branch do we have? Ew, main. Okay. Git submodule init recursive. It's not even that Docker is bad software. Docker itself might be totally fine software. It's what Docker encourages and enables.
Yeah. Okay, Docker. Oh, not even. If software stopped depending on everything, then good. We're building something. Good. We have NC Risk. All right, let's get Visual Studio Code up here. And let's start exploring. What do we want to explore? Do we want tt-metal? Like, what even is this? That documentation page looked okay. Let's see.
let's see if there's anything interesting that like. Okay, this looks kind of interesting. Okay, build a project following that. Great. Okay, I kind of like this. Let's see if we can import tt-init. No module named tt-init. But yeah, I mean, this looks kind of interesting. Not with Torch, but can we just do this? Why do I need to divide? Zero is fine. That worked. How do I install this? Installation guide. And ops and tensors. Okay. Installation instructions. Okay, we did all of that. Developer dependencies. Let's do this too. Great, we're gonna download all the LFS crap. Set up the environment. Note that this setup is required every time you want to use the project. Ugh, no, whatever. Pep8's disgusting. If a standard rejects the God tier 2 spaces, then we reject the standard. Like, I'll tell you the problem with strict formatters. The problem with strict formatters is you can no longer tell who's a good programmer by looking at their code or not. Like, one of the beauties is I can look at a pull request, and when people like have like a variable and then like a space and then equals and then the thing right there, I just know they're not a good programmer. Okay, because they don't pay attention to detail. If they had a PEP8 formatter, I would never see that about them. And, you know, that would you'd just be losing information. What are we downloading that's multiple gigabytes? Oh, we have to download the weights for Llama 70B so you can run that example. Well, that's sensible. Alright, so we don't have that yet. Oh, did this do something? Okay. Let's try the example in this pipeline. No module named py-buda, but I installed it. Oh no, never mind. I'm sorry. Third-party Buda backend, device bin, silicon wormhole, create Ethernet map does not exist or is not a regular file. Great. Okay, well, let's just try the metal thing because Buda didn't work. How am I ever going to claim this $500 bounty? Should I just try Hoarder on this? TT to unknown torch library. Oh, now we have all this. Oh, I think torch vision didn't work. Maybe? No. I installed the exact wheel they wanted. Let's try to figure out where this thing is. X9000 uses the 2.0. It does not seem to. If you need to compile with other versions of Torch, you need to recompile. I use the exact same version of Torch. Now let's uninstall and reinstall Torch. Maybe it'll work better. Using this exact wheel. Let's download the wheel. No, Torch works great. It's just when people try to link to it. It's linking that's the tragedy. Oh, here, we have this Torch audio garbage. Let's uninstall that. Okay, I have a new theory. This version of tt-buda might have been built against a different, which release did I download? We can look at my wheels and take a look. Okay. DevGS, this one. All right. So this happened on January 5th. So let's check out this commit. Okay, now let's look in requirements. This doesn't even have requirements anymore. Where's Torch? Great, this one doesn't even have a Torch. Version that I'm supposed to use, but this is probably the wrong Torch version. How's this supposed to work? Oh, well, okay, that doesn't work. Which version of Torch should I use? PyTorch 0.2, that's the one I have. All right, let's try one more thing. I don't know what this CXX API garbage is. Let's try it without that. So that's the Python we have. tt-buda seems obsolete. Did this Chinese guy figure it out? In addition, when packaging the wheel, you need to avoid modifying the... There's not even a setup.py anymore. What is this? This is not even a version.
These people need tinygrad support without dependencies. Yeah, it takes me a while too. This is bullshit. I mean, like, you know, like I'm kind of like, this is like, should we?
All right, let's try metal for a bit. I think we're giving up on Buda. Like, I'm not spending my time figuring out why the torch library symbol's undefined. Like, stop writing code like this. Oh, okay, it worked. Don't use the torch they tell you to use. All right, great. Okay. All right, it did something. Phew, finally. We got to keep an eye on the temperature. All right, we're doing okay. All right. Look at all this stuff. I mean, this is kind of pretty. Creating input Q connector. But that wasn't in the docs. All right, should we write a little benchmark? Want a benchmark? Let's see what is a tiny. Wait, I have to make a module? py-buda PyTorch module? This looks so hard. Alright, does this work? Let's try a smaller matrix first. No. Error while pushing inputs. Okay, so maybe I have to like make it a batch or something. Okay, that seemed marginally better. No. right. Let's start by copying their example exactly and then figure out where it breaks. Oh, do I have to tell it it's a torch NN parameter? Fine, I'll write out torch.matmul if that matters. I'll make it 4. And that should pretty much match, right? Oh, let's stop doing it 3 times. That might have been too much to ask for. This Tenstorrent card might be a one-time thing. Uh-oh. It's getting hot. No, it didn't work. Okay, let's see if the old test still works, or if I broke the card. We broke the card. Okay. Can I reset the card?
If you thought AMD was bad, try a Tenstorrent card. Is it hot? No, it's not hot. We're fine. I mean, that's not too hot. That's not that bad. All right. Does tt-smi support reset? Oh, here we go. Do I want to generate a reset? Oh, I can generate a reset file. I can generate a reset JSON. Fucking joke. Oh, yes. Here, update the generated file and use it. Reset. Reset expects 1 argument. Okay. That works reasonably. I don't know why that didn't show up in help. Oh, it is there. Okay, I see. It just confused me with generate reset JSON. All right. Let's see if the test works after I reset the card. Okay, good. We're back to, it's working again. All right, let's see if my benchmark works. And that was actually not that bad. We just had to reset the card once. I mean, we asked it a lot. We tried to multiply a matrix. That was, okay, good. This worked. Okay, now let's make said matrix. Can I change that to 1 or is that going to break? All right, not too bad. Let's try looping it 3 times. What do we think? Will it work? Can the Tenstorrent card do 3 multiplies? No, I know. That was not that bad. We're not hating, boys. Oh, well, don't do that. Definitely don't try to run something multiple times. That was too much. Alright, am I just not reading the API correctly? Alright, let's play with metal. Did I break it? Don't do it 3 times. That's too many times. You can multiply 1 matrix per time the software starts. Can I make the text bigger? No, but I can let non-subscribers not talk. That's right. There you go, it's bigger. Are you happy? 1 matrix, 1 reset. That's the law. No. To be fair, you run the program multiple times. Great. Now see, this is the opposite of how you do complexity, guys. I want food. Is it Uber Eats time? Oh, I know what I want. Shanxi Magic Kitchen. Oh, wait till you guys see Shanxi Magic Kitchen. Shanxi Magic Kitchen. Oh, yo, by the way, folding phone. I got a folding phone. I want to reorder from Shanxi Magic. No! Shanxi Magic Kitchen's not open right now. Nowhere's open right now because it's 9:35. By the way, look at the size of this folding phone. You can see the crease from here. Hang on. What do I want to eat? Oh, this is all disgusting. I'm gonna eat disgusting food. Never mind, all this food's disgusting. Wow, py-buda is actually pretty decent and practical. Good point. Oh, because I have to recompile it? I mean, that might work, but if that does, I just, yeah. No, I don't want coffee. I want Shanxi Magic Kitchen. No, I want Thai food. That's what I want. I want some noodles. Can I get some noodles or some fried rice? When I was in India, I saw a sign and it said fired rice. I'm like, where'd the rice get fired from? No, there's no Thai food available. But I could get Pho Nam Kali, which is very far away. It's almost 10 o'clock. I could just wait and be patient. What do you think of that? Or do we want a bagel? Bagels are disgusting. Like, I eat bagels and then I'm not happy. Taco Bell. Why is all disgusting food open? Alright, should we get an acai bowl? No, we'll get an acai bowl. Bigger bowl, yeah, bigger bowl. If I add $2.01, I can hang on. So if I order from another one, if I bundle a Crondy from Randy's Donuts, does that count as Uber? No, you can't do that. No, that doesn't work. I'm trying to save $2.05 with Uber One, but I have to buy more stuff from the place, and all the stuff from this place is expensive. All right, let's get Alex a juice. Here, perfect. Great. Okay, my acai bowl will be here. Yeah, spend more, save more, right? Like I just feel scammed. You wish you had money to eat? Well, don't buy a Tenstorrent card because then you won't have $800. But if you want this joy and if you want to experience this joyful experience, buy a Tenstorrent card. All right, let's see if we can use metal. We got it working. We got it working. It wasn't too terrible. I mean, to be fair, like as a dev kit, this is pretty decent as far as dev kits go. It's on the dev kit spectrum. Let's install this. Python 3 setup py install. Arch name's not provided. Well, we know the arch name, and it's Grayskull. No, we don't have dev mem map. Great. Or the impl device. Do we have wheels? No, they're wheels for TT metal. Release. Okay. Is this a wheel? No, it's a zip file. Alright, maybe we should try a release. Maybe the releases work. I think that's what one of the things suggested. Let's check out that tag. Wow, thank you for gifting subs. See if that works. No, problems with dev mem map again. Okay, so question. If I have py-buda installed, does that mean I have ttnn installed? No, definitely not. Okay, so that was a false hope. Did most of these. Let's try this. No, wait. I'm gonna try to clone. I don't know. You want to just try it again? Let's follow the instructions exactly. Why was I not? I don't really want an acai bowl. Why was I not just patient and waited for Shanchi Magic Kitchen to open so I could eat chicken and noodles, which is what I really want? Ethan 1G, you should know better. It's not for anything. It's never for anything. Oh.
is 4 things. You know, I try to explain this with like the marketing for the tinybox. Like I'm like, stop saying what it does and start saying what it is. I hate all these like no one sells food by what it does. Right? People sell food based on what it is. I can respect food. You know, you can respect. No one tries to like tell you like this burger will complete you. No, you say what it does. People just need to focus on. If everyone would just focus on describing the world accurately. Okay, we need these teaching metal home. Do we need these right? Python path. TT metal env. Good, we installed wheel. Let's just reset it. Resetting it was very enjoyable. Like, why is the core power so high now? I remember when it was low. It's a little lower now, it's good. We're building TT metal from this version. And then we can get started. TT managed. Ooh, this is kind of cool. Oh, look at this graph. Oh, that looks cool. Why does everyone try to like make it like work with Torch? Like it's never going to be good. Maybe AMD will be good because they built literally CUDA clone. Single core and multi-core. So I mean, this actually I hate this crap. Oh, this is why HSA failed. Like, stop trying to make everything generic and just make your shit. Like, explain to me what the Tenstorrent thing is actually very cool. Like, the accelerator is very cool. I visited them. They explained it to me. It's just a shame that they don't like explain this to you. They're like, we're building a generic API that's going to derive business value. Like, no. Stop saying what is it? User friendly, intuitive, familiar with fucking PyTorch. Why is your low level shit PyTorch? Oh, maybe there's something lower level than TTNN. Alright, well, this is all open source, so why don't we just start reading the code for tt-buda? py-buda. And then we can see here, okay, py-buda, we have something called PyTorch module. Maybe we can like see what this actually does. Ooh, la guru, great. What is this calling into? At the lower level. Probably tons of C code. I do like that they've lifted that their metal thing is Python. Like, you want your metal thing to be Python, but then the question is, does it actually use that? One of these files is longer than tinygrad. Yeah, make something that works for your thing, exactly. What do you want to know from semi-analysis? I should pay for how much is semi-analysis? I should pay for it. Is it expensive? Oh, they have a Substack? 700? That's kind of a lot. 700 a year or a month? Good, we're installing a lot of stuff. A year, that's not that bad. Okay, dependencies. tt-lib is a unified to the tensor argument within tt-eager. But I think tt-eager is part of tt-metal. The amount of code in this stuff is just crazy. But like, this is what happens. This is what happens when you just employ software engineers. You get an insane amount of code that can barely multiply a matrix. But no, you're just not using it right. Yeah, well, who's gonna use it right, you know? Like, if I can't use it right, tell me who's gonna use it right. All right, let's see. Let's give it a fair shake and see if I can fix my thing and see if there's some docs that explain why I can't put module run in a loop like you'd obviously expect. Run inference, inputs, input, output Q, get. Oh, maybe this something I can. This just calls run inference, which calls this shit. Why, when I look in run inference, what it calls is underscore run inference? Why is there an abstraction layer there? Oh, of course, we're going to get devices in this complicated thing, and then we're going to run devices inference. All right. And then if not resume, we're going to initialize that. How does anyone do it? Oh, yeah, we're going to start a loop thread. Unless we're in sequential, we're going to check the sequential override. Like, how does anyone do this? Oh, great. Thank you for building an environment for me. Do I have TTNN now? No, of course not. Wait, that has TTNN? That's just weird. No, don't install it in a... Do I have a wheel somewhere? Can I just install it globally? No, I want a TT metal wheel. Python 3 setup installed. Arch name equals Grayskull? Come on. No, wait. You already built this. Why are you building again? Don't build again. Please don't build again. Please don't build again. Okay, it looks like it's not using a ton of CPU, so it's not building again. Maybe. Enterprise companies have code complexity tools that want 5,000 tiny functions. Like, I hate this. This is just, this kind of code is just like, please have a million bugs. Yeah, oh, look, well, good thing we're in sequential override mode and we can run forward inside a thread. All right, let's look at run forward. Okay, here we go. So where does it actually run the fucking thing? What does run command do? Where do I get to? Okay, here we go. All right, now we have a device. Okay, push to command queue. Okay, self command queue push. Great. All right, so we're deep in here and we have a device. Now, what actually gets pushed to a command queue? Can I like look at a command queue? Send the shit to this. This is block. Oh god. What is this? What's being pushed to a command queue? You put types on all the useless shit, like the queues, but you don't put types on the... Oh. Well, of course this doesn't work, because it doesn't have weird-ass old version of Torch. Missing parentheses in call to print. No, 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 no. No. How do I create a wheel? Can I make wheel? Is it like that? Wheel? Okay, well somehow it's set up, but I had to use this virtual env. And you know how I feel about virtual envs. I hate them. Well, that Python 3 doesn't work, but if I do Python 3.10, for some reason I can import ttnn there. Let's see if that works. No, well, that's the wrong ttnn, so it doesn't work at all. Never mind. If I do the one in Python 3, maybe I have to go here when I import ttnn. But that doesn't work because there's no pyframe get back. Okay. Why do you have py-buda and tt-metal, but py-buda doesn't use tt-metal? Let's have .c. Oh, the fucking PyTorch garbage. So where is any of the code that actually does anything in this thing? No. It didn't work for me in 3.10. It never actually worked. It just imported the import.py file, basically. I like that there's a script. I like that there's a script that counts the lines. This is very tinygrad inspired. Let's see. Let's see how many lines it is. Okay, never mind. All right. Why don't we look at tt-smi? Or should we try to claim a bounty? Do we want to actually try to use their... No, I'm not dealing with that. That just sounds awful. Yeah, I know. I love strace, right? Let's look at this thing. I have it here, don't I? No, I don't. We'll clone it. Okay, imports tt-smi backend. What is the luwen? What is that? Oh, Tenstorrent system interface library. Oh, of course, there's a custom. Okay, well this is useless. Is this all just in like C and there's no way I'm ever gonna like be able to do anything with this? How do I like talk to the device? Where's like the code that talks to the device? Does this have code that talks to the device? You know, dist. Dist is what I want. Dist. Okay, good. We got an egg. All right, let's pip3 install this egg. You can't just install an egg. Why not? Ooh, let's upgrade pip. That sounds nice. Better pip. Maybe better pip can install an egg. What is an egg? Why can't I install an egg? Cannot find a version that satisfies the requirement. Force install my egg. That didn't work. I didn't have high hopes for that. Was that dist always there? Python install egg file. How do I do this? How exactly does one install an egg file? Oh. Python setup. You do this at the setup tools page. Ooh, easy install. Perfect. I love when things are easy, okay? Let's spell it right. Don't have easy install. I don't know. pip3 install easy install? Alright, no module named easy install. You think easy install would be difficult? I knew easy install was hard. Oh, it's called setup tools. Setup tools? Setup tools is already installed. No module named easy install. Easy install? This is not easy. Is it a real egg? Zip archive data. Oh, great. We got .c. A whole lot of weird. I don't know. Like that might just work. Maybe. I don't really have high hopes for this. Maybe it worked. ttlib.device. Alright, let's see. What is supposed to be in ttlib? Import ttlib as ttl. Okay, let's see. Get num PCI devices. If this function works, no, of course not. Well, we don't have a YAML. Of course. How could we possibly expect it to work without a tt-metal YAML shit? Device descriptor. What the hell? Do we have that YAML file somewhere? Oh, I probably have to set like the. Those things I had to export. Here we go. Let's try tt export tt metal home equals home Kafka Tenstorrent tt metal. Now let's see if we can do this. Okay, good. We've detected one PCI device. Okay. We're making good progress now, boys. Good progress. How do I install the egg? Let's install the egg. We don't have to do ZZ anymore. Pip3 install the egg. Install the fucking egg. Easy install. Okay. Let's ask labs. Ooh. Claude 3 Haiku. How do I install an egg file in Python? Download the egg file. Open the terminal. Pip install the fucking egg. Oh, not compatible. Use a virtual environment. Force install egg. No binary, no deps. I don't know. Let's try. What does no binary do? Bypassing. Yeah. I love bypassing. All right, let's go. No binary requires an option. All right, well. You must give at least one requirement to install. I need a package name. tt-lib? As it can cause more problems than it installs. Ignore installed. Okay, you know what? I have a better idea. Where is my Python? Whatever. This works. Right, let's go to my metal here. I don't know about ttnn. Sys.path.append, that shit. import sys. We need to also import os.environ. Oh, make the text bigger for the noobs. Well, you know, noobs, you get that size text, okay? So be happy. Where did I make that finally do something here? What did we have to do? tt-metal home equals this. All right, let's import ttlib as ttl, and let's print this. Okay, good. It'd be nice if that actually worked. I can make that work by. Oh. Wait, it actually installed? What? The egg installed. Okay, whatever. So I don't even need that. Great. Okay, good. Good. Alright, we can get the number of devices now. Great, we're making progress. So all that stuff was actually tt-lib. Maybe tt-lib is tt-metal and ttnn is like right here, and let's see what this actually is. Okay, well this all looks like nothing. How much code is just nothing? Definitely don't care about that. Oh, and here I have a so file. I can just import that. That's the one that doesn't work. Alright. Let's try to like talk to this device and like have it do something. Eager? Tensor. Oh, C. Create a device? I think I tried to do that before with ttnn, did I not? Whatever. Alright. Yeah, those things sound good. I'm glad that we're designed to support multiple devices. This is a great use. Alright, good. We have an AI clock. Alright. Labels, torch to tt-tensor. Oh, it closes the device for you. That's pretty nice. Let's see what's here. Tt-tensor shit. All right, we can make a tensor. Let's make a tensor. It's a pi tensor. Oh, it's like a torch. I need a torch tensor? Really? Of course, there's no definition found for tensor. What's a TT layout? Oh, tile. Sounds good. Tile is where I want to have my tensors. TT D-type. Tensor reshape size. I don't know. What if I make a tensor bob? Is that gonna work? Nope. Don't make your tensor bob. Alright, fine. I'll import fucking torch. Import torch. Torch dot brand 1010. D type equals torch dot bfloat 16. TT. No, that's a terrible name. We'll call it PyTorch underscore random underscore tensor. Yeah, who likes my large variable name? That's right, it's a large variable name. Okay, let's go. Does that work? No, don't do that. Index is out of bangs for the rank. Should be between 0 and 0, however is fuck you very large. While size is less than 4. Size insert at 0. Oh, we have to put ones. Oh, of course. I'm very sorry, your torchiness. We need to put some ones in here. All right. Now we can put it to a little tile layout. Yep. Nope, that didn't work. Okay, well, that didn't work. Is that what this does? Object 1, insert at 0, and it's putting the shits there. Okay, well, you know, I don't know. Maybe that's an offensive size. Let's try 16. No one has ever been offended by 16. No, 256 is the least offensive size, I'd say. Of all the sizes, I'd say 256 is the least offensive. Okay. Well, that has to be like a tile. I don't know. Like that. TT constants, tile height. I don't know. Let's see. Can we get that? No, it doesn't have constants. Here we go. Tile height equals tile dim. Tile dim is 32. Oh, 32. Of course. Okay. We have a TT tensor now. Let's take a look at our TT tensor. Let's admire it. Can I use IPython? Of course that doesn't work. Pip3 install IPython. And I can tab complete. Please restate current task. Ugh, God. Do you live life like that? Look, we have a tensor. Do you live life always thinking about what you're trying to do? That sounds so terrible. I am just trying to eat an acai bowl, and hopefully it's here. It's not here. Should we ask the phone where it is? Large folding phone. Where is my acai bowl? Oh, look at that. It's using very little power. That's good. What do I think about Devin? I think it's a hype. I think it's hype. I think that hype fuckers should, you know, just die and stop hyping shit. Like, can I use it? Can I use it? Or is it hype? Or did you release a video with blurry shit? Right? You know, all these companies, you're going to build humanoid robots. Like, it's so laughable. It's like, wow, remember when we were going to solve self-driving cars because self-driving cars were the easiest robotics problem? Everybody proceeds to fail at self-driving cars, and then they're like, oh, humanoid robots! You know, you just can't with them. I don't know, you know what? Be happy that you don't understand. Okay? If you don't understand, if you don't understand what's going on with AI, and you don't, just be happy. Be happy, because if you did understand, you'd just be infuriated all the time. Oh, AI, I don't even know what jobs people are going to have in 18 months. Dude, I wish these people would put their money where their mouth is so I could take it all from them. Not because I want their money, but because I want them not to have money. Right? We'll burn it. We'll burn it in a big cash fire. I think my acai bowl's almost here. So that's exciting. Okay. All right. We have a tensor. Well, let's look at some of these. Let's look at some docs. Let's read some docs. Some of these docs actually looked kind of useful, except I don't understand why I have tt-lib and not ttnn. But tt-lib sounds better than ttnn anyway, so. Luwen and tt firmware, and why Why are there no TT? Oh, here, TT metal. Why is TT metal in a completely different docs from the other thing? Not TTNN. I don't know where. Using tt-lib. Tt-lib operations are missing some of the features. Print L1 buffers. Does TTNN work? No module named TTNN. I thought I saw a TTNN. Maybe this will just work. Okay, okay. No, it didn't just work. Why not? Oh, no module named TTNN, TTNN. Oh, I see. It just didn't do the... Here, we have an egg. No, it's a tiny egg. We need a big egg. Okay, this. Okay, we have to copy this to... This should just kind of work. YOLO? Now we need loggeroo. Okay, that's not too bad. I can install loggeroo. No module named persistent. Persistent collections. Okay, this just looks like something I can pip install. And then we'll have working TTNN, and then we can use the TTNN examples. Oh, graphics. That's a normal ass library. Good. No module named tt-eager. Oh, now we have a problem. Thank you for gifting subs. Okay, well, we have tt-lib, so whatever we can do with tt-lib, we can do. I don't know why we don't have ttnn. But ttnn looks crappy anyway, so whatever. Converting to and from a torch tensor. What were the cool things where they were telling me about, like, DRAM and shit? Like, that I'm interested in. Anything that involves torch, I'm not interested in. I want to, I want to, not all single core. Creating DRAM buffers and circular buffers. Oh, this is in C now. Create buffer. Where can I actually, like, use the... Maybe let's look at some of those things that example prints out. No. Oh, no. py-buda only works in Python 3.8, of course. Gotta remember that. All right. So we have py-buda tt device, create input device, Q connector, balancer, whatever. Like, I just want to bypass all of this. I want something... The Tenstorrent chip's actually very cool, and I wish they would just expose... Like, they should stop with this. Jim, stop. I told you this. Like, nobody wants any of this shit. Nobody wants a 50% torch. Like, be proud of what the chip is and expose the chip for what it is. The chip's really awesome. The chip has, like, all these tiny little RISC-Vs and they can talk to each other. But instead, they put 7 layers of neural network crap on top of it that nobody wants. And it doesn't work. Right, this was my advice to Tenstorrent. I'm like, expose your chip for what it is. This is the only way this is ever gonna, like, get traction. You know, explain why you're not, because right now, all you are is shitty-ass CUDA. It's like CUDA, but it doesn't work. Oh, yes, that's what I want. It's like CUDA, but it doesn't work. Even ttnn is too. Can I get the docs for tt-lib? Does tt-lib have docs? And is this the lowest level thing? Because, okay, the chip is really cool. The chip is like a grid of RISC-V processors, and they can all talk to each other. Yet I see nothing about this. I see all this crap about, like the stupidest thing you can do today is try to build a large language model inference engine. Like, that's the most competed in space. And you're all just going to lose to NVIDIA, okay? Like, if you try to do that stuff, you're just going to lose to NVIDIA. If you, like, say, look, we built something different, because this is different, and this enables new capabilities, you're never going to leave. How about this? Same thing to AMD. Same thing to AMD with HIP. Maybe HIP actually kind of works. Like, maybe HIP kind of works because the NVIDIA and the AMD chips are actually very similar. So you might be able to just shove your way through. I think what Apple's doing with MLX is cool. Like, it's like they're taking pride in the things that they can do uniquely in Metal. Whereas what this is just a crappy version. Like, why? Here, tt-metal is designed with the needs for non-ML and ML use cases. Yet your whole thing is talking about language model crap. Language model crap that nobody's going to care about. Look, the only way this company succeeds, this chip, I mean, this card is fine. I'll buy it for $800 because I think it's fun. But no like real company's going to buy these. Right? No real company should. If I was in a real company and they're like, we're using Tenstorrent cards, I'm like, this is what happened with Dojo. Same thing. Right? No researcher wants to use this. And as far as like price per dollar on inference, you're not going to compete with other people on this. You have to be in this for 10 years, right? Like, TinyCorp's in it for 10 years. Tinygrad will still be relevant when large language models no longer are. Here you say it's designed for non-ML and ML use cases, yet this whole thing goes on to talk about TTNN. Designed to be intuitive to a user that's familiar with PyTorch. Bro, Wayne Gretzky, don't skate where the puck already was, skate where the puck's going, and it's not going to fucking PyTorch. And everyone knows this. TTNN is based on top of Metalium. Alright. So where are the docs from Metalium? This? Can I use this? No, this is only in C. Don't make me code in C. Oh, here. Oh, tt-metalium here. Oh, okay. I missed this. Okay. This is. I didn't. The whole thing here was ttnn. I didn't realize this was a separate thing. Open PyTorch, man. Okay. All right, boys. We gotta leave Python. It's time to go to C. No. We're gonna code to C. No. Okay. tt-metal programming example loopback. Make. Make. Loopback. Currents. Loopback DRAM copy. Nope. Okay. Make programming examples loop back. Okay, let's try this. Make programming examples loop back. Nothing to be done for programming examples loop back. Export tt-metal home to this. Export arch equals Grayskull. Is that an E or an A? That's not an E, that's an A. The dude wants to give me a massage. He's gay. Make build. Program examples? Maybe down here. No such file or directory. Okay. No such file or directory. Oh, because this is tt-metal home. No dev map. No impl device. Did I spell Grayskull wrong? I did. Grayskull has an A. Oh, here we go. Build programming example loopback. Okay. Oh, no, that's not going to work because we have to. We're just going to add this to my bash shit. These people, it's AMD too, like they focus on all this high level stuff and you don't want to focus on the high level stuff. You want to make your programming model unique and awesome. Such that people want to use it. Okay. Build programming examples. Does it run? Okay. Cool. Test passed. Alright, let's see what that actually is. Programming examples are in tt-metal. Metal programming examples, loopback. Okay. Oh, don't do slow dispatch mode. Okay. All right, we create a device with device ID 0. I don't know why it's on a new line. Then we create a command queue, and then we create a program. This is very OpenCL shit. And we create a kernel. DRAM, create random vector. Smurfy, thank you for gifting subs. Okay, we write the buffer to DRAM. Runtime args. What are not coordinates? Is this stuff documented? We get data movement kernel. I missing something that just kind of explains what this is? Like, it just explains what the Tenstorrent thing actually is. What's a knock? Does it tell me what a knock is? It sounds like Urbit. SPFU, SP. Oh, we can make the chat VIP only. A single core. Okay, this stuff is much more interesting than what I was looking at before. Let's read some actual kernels. Let's read their manual kernel. Wow. They should just port tinygrad. Like, they should expose this API, which is the most sane API I've seen from them. And they should expose this API to Python. Knock might mean network on chip. Do we have anyone from Tenstorrent here? Okay, knock is network on chip. Right, so those are the args that we pass into the program. Physically independent to knocks. There's only two? Like, where are my cores? Where does this shit actually execute? This is the font. I'm disabling it. This is normal Chromium. Create kernel will specify the kernel and core range on which to execute. Core. Oh, so this is just running it on one core. But there's lots of cores. So if I read like the mapmul multi-core, it's going to use multiple. If I look at the create kernel, all cores. Oh, I see. Where do I get all cores? Split work to cores. What does this return? Core range set. I see. So how many cores are there? $120 cores. our grid of cores. Each core includes 5 RISC-V processors, 4.5 megs of SRAM. A jump scare, right? Okay. I wish that this was all exposed to Python. Wait, is it exposed to Python? Is there some way I can like create a kernel and launch it in Python, like py-buda? Okay. A Grayskull is okay, that makes sense. 10 by 12 grid of cores. Now this is the documentation. Why isn't this the front page of this? That would be cool. Yes, like this explains, this makes me understand things. So where are my knocks? I thought there were 2 knocks. I don't see 2 knocks. I just see 120 cores. Ah, yes. Wait, this is the best stuff. Why don't you have this on the front page of this? What is a knock? Oh, here. Knock is a 2-directional bi-D torus. The knock connects all the cores. Okay, I see. We have PCIe, and then what's ARC? I mean, I guess it's the network stuff. Okay, but that's there. Cool. So if I'm just using that core, how do things get to that core? This is okay. This should be linked right on the front page of Metal Gear. All right. Each core has 2 data movement kernels and a compute kernel. Knock async read from a buffer. Well, I said he has 5 processors on the things. Look at the basic data movement kernel. Reader binary, okay. Alright, so yeah, I think understanding the matmul thing is good. I think maybe I'll try to write my own matmul outside of this stuff, and that'll be today's stream. This doesn't have an Ethernet, so I don't know what ARC is. What's ARC? What is this Excalibur thing? Oh, cool. What is ARC? I guess I thought it was Ethernet, but these things are Ethernet. to stuff. Arc is just a CPU that is used for system management. Okay. All right. Let's write some programs. First of all, I hate coding in these sort of environments. Let's create a clean. We'll call it tt-twitch. We'll call it Tenstorrent Twitch. We'll call it Twitch Torrent. tt-twitch. Keeping in the Tenstorrent name. All right. Let's see if we can get a little build environment up here. Okay, now that the Tenstorrent guys are here, I'm more motivated to try to not be a general fuck like I usually am. Alright. It is in C++, so we do need CC. Create the device. I don't know why we need to define device ID. Let's just do that. What do we need to include for that? tt-metal host API? Well, that doesn't exist, so we'll figure out how to do that. Let's run.sh. Love run.sh. Shebang in there. Clang main. Where is this host API thing? TF metal. Did I do TF metal? Yeah, I did TT metal. Alright, so we'll just throw an I on there. We don't have common assert. Where is that? Okay, we also have to do this. Alright, we gotta find format color. Third party format. Okay, well, what is that? I can use that same, I'll use that same environment variable you guys do. tt-metal home. I can just say tt-metal home equals that for now. Spend time building a good build environment and it will pay itself back 10 times over. And that, attach I, tt-metal home, that. Okay, well, that's great. Lots of shit doesn't work. Let's go to loopback, host API, that should just work, I think. Let's figure out what's not working. Oh, I probably need to say it's like C++ 11 or something. Enable a new C++. What is that? Claim scan C++ 11. CCC. That sounds good. Alright, now we're back to dev memmap, but I've seen this one before, and this is because of you have to tell it it's Grayskull. Yeah, so that's in here. Whatever, I'm just gonna only for Grayskull, whatever. I'm gonna put a comment because only Grayskull cards are shipping, so this will work for everybody. TT arch types. mean, this is actually interesting. I'm kind of curious what's in this dev mem map. Mem maps are always very interesting. You learn very interesting things from mem maps. Cool. UMD? What's UMD? Why do I need a UMD? Host mem address map. Oh, we need that too. What's UMD? Oh, we got some Rocky. All right. Oh, user mode driver. Okay. Great. We'll include some stuff for the driver. Got to do that. Okay. Dev messages. All right. We're getting somewhere. We're getting somewhere. Maybe. Who knows? TT Metal Hardware Inc. Okay. Straight up hardware Inc. Don't need Grayskull. Okay. Certain explicit cast to silence this issue. I don't know. C++ 14. Nope, don't do that. Okay. C++ 20. It's 20. Non-constant expression cannot be narrowed from type shit to shit. Let's see if I can figure out what arguments they're compiling with here. This could just be some way to ignore this. No. You don't want to, like, just make another example and reuse the existing build system. You'll never learn anything if you do things like that. Okay? If you just use what's handed to you, you'll be using what's handed to you for the rest of your life. See, this is why I don't stream anymore, because I'm sick of saying things that supposedly sound like things, you know? Just, it sucks, okay? I don't know, where? Main module MK, yeah, that's kind of what I'm looking at. I'm looking at that right now. It is this, right? God. Oh, let's just fix that. Insert an explicit cast to silence this issue. What is that? Okay, great. Undefined reference to tt-metal create device, and that's because we're going to have to link to some shit. Okay. So rip grab. Build lib. Only this. And then we're gonna have to link to, I don't know, like device. Start there. Okay. We just need a little YAML. YAML. Not find Y YAML. YAML. Get rep YAML. Yeah, just orchestrate it with Kubernetes. Great. How do I link to YAML? Y YAML CPP. we're back to undefined create device. Okay, it just looks like these. So let's try ltensor LTT metal. Maybe just LTT metal. Let's just try that. Maybe we don't even need device. Let's just try that. Maybe we don't even need YAML. Let's get rid of YAML. I want to do the minimum. You always want to do the minimum. You don't want to start linking to the world. Everything needs YAML. We love YAML at Tenstorrent. Alright. Cool, we built something. Alright. Building. Throw a quick readme on here. Tenstorrent example from Twitch. We'll deal with pushing later, but yeah, so that cannot load shared library lib tt-metal. Okay, where's the library? Build lib. God, there's so many to do this. Whatever. Build lib. Okay. Now we just have a problem with that. Okay. Environment variable tt-metal home is not set. Export. But I thought I set that. Okay. Process teardown with device still active. Okay, that's a lot better. I think I might even be able to remove that send link now that I actually did export there. I don't know why it wasn't. Okay, good. Process teardown with device still active. Okay, we can fix that. We have to, after we create the device, we have to close the device. Let's pass. Oh, it's just like. Hey man, you can't include because you gotta include the shit for a cert. Okay, great. Good progress. Good progress, boys. Good progress. Alright, let's create a command queue on the device and a program on the device, of course. Then we have the core coord is 0, 0. That sounds good. Yeah, that's fine. Let's create a kernel. Let's just not be too specific about what type of kernel it is. Program, we're going to call it kernel.cpp. We need that core expression. I have no idea what that data movement shit is, but we'll get there. Alright, let's make a new file called kernel.cpp. Let's look at the simple kernel. Let's make a kernel that does nothing. Hopefully it's capable of finding the compiler and shit. No suitable, what? Too many arguments in function call? Where is this auto-completing from? Why does this not think it has the right? Why does this have a different thing than that? understand. Like, why, when I mouse over this, does it think that the types are int and shit? Oh, maybe there's 2 of them? And it's just stupid. Okay, that's reasonable. It's actually pretty reasonable. Okay, host API. All right, cool, 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 cool. That's good. All right. Did it compile my kernel? Let's put crap here. Compile my kernel? It does not compile my kernel. Okay, we'll probably need a compile or something. Create kernel, DRAM config, create buffer. We don't need buffers. NQ program. Let's go. Finish. That's nice. Why is false not good? Too many arguments in function call. I see. What? I don't understand why all these like type hintings are wrong. They look right when I look at them. Now this blocking operation. Yeah, that's good. Why don't I just block and don't have to finish? Whatever. Okay, no such file or directory. Great. So everything, unfortunately, is with respect to the metal thing. So let's just do that. Now, can you find the file? tt-metal-env equals dev. No such file or directory. Oh, I see. So even though I put in an absolute path, it still doesn't work. At least the errors are good. All right, good. Crap was not declared in the scope. Good. That's exactly what I wanted to say. All right, let's remove the crap. Does it run an empty kernel? Great, it runs an empty kernel. Why is it so slow? Why does it take so long to turn on? That's slow. Okay. Let's take a look at Atmos and see what we can learn. It's JIT compiling your kernel. All right, that's cool. Yeah. Core range, that looks more useful. I don't like core coord. Oh, that's cool. I don't need to call create program. Create program is just nothing. I can just do it like that. That looks better. Whatever, we'll call it create program. I don't trust C with its like vampire assignment shit. All right. This is a lot of work to create a buffer. Why is it tiled? What does this stuff mean? Is that in the docs? Just explain to me the tiles. Interleaved buffer config. DRAM config. Why is it tiled in DRAM though? Oh, it's not tiled in DRAM. I see. It's just called that. Device sizes. Why is the page size the DRAM buffer size? That's sketchy. All right, let's make our matrix 1 or 2, 4. 2 for the bfloat. So bfloat 16 is 2 bytes. I assume this is in bytes. Buffer type equals DRAM. Probably need to include some crap for that. Alright, that's a later problem. Page size equals 1. 1 page size. That's a good page size, right? How's 1? We need some semicolons. Oh. I put a semicolon after that. Okay. Let me throw some E's on that bitch. Throw some E's. There we go. Alright, use of undefined identifier, shit. Which one could it be? I don't know. Details, TT metal? Is it in detail? It is not. Where is this defined? Impl buffers buffer. Do I import from impls anywhere? No. Okay, fine, I'll import from impls. Impl buffers buffer.hpp. Let's go. Doesn't work. Oh, I gotta like use a namespace or something. Using namespace. Love namespace. Oh, using namespace TT. Oh, maybe it was fine. I just needed a namespace. Alright, great. Love it. Gotta love that C++ garbage. Oh. I'm tired. I'm an old man. Alright, we have DRAM config now. Alright, let's see if we can create a buffer. Why do these not work? Hello.
Hi.
I got you a green juice. It's in the fridge.
You got me a what?
A green juice.
Oh, thank you.
Welcome. Why doesn't that work?
I
Look
got
at.
you more bananas. Page size must be divisible by this shit. Oh, well, I knew my page size was tiny. All right, let's make my page size a very normal. That's a normal page size? All right, good. We have a normal page size. All right. Let's call this buffer M1 DRAM. Let's first do an element-wise addition of these two, and then we have M2 DRAM. And hopefully I can reuse that. You know what I want? I want Shanshi Magic Chicken. And we're going to get some Shanshi Magic Chicken. We're working hard today. I really didn't want that acai bowl, and I don't know why I bought it. Shanshi Magic Chicken! You guys ever seen me get Shanshi Magic Chicken before? It's delicious. A sauté spicy chicken with hand-pulled noodles. Okay, so we got 2 DRAMs. We made some DRAMs. Ooh, we can get some addresses. All right, cool. Let's give them better names, like source 1 and source 2. And by 1 and 2, I mean 0 and 1. Okay, well, they call them that. DRAM buffer. It's a little explicit. Okay, we'll be explicit. This is C++. We should have long variable names. Let's print these addresses. Is there a way to get more debug information that'll like print about the allocations and stuff? Yo, that's cool. That's cool. How they're just like, wow, I can like see what the numbers are. That's cool. I don't know what the first 820 of the DRAMs used, but that's pretty cool. Okay, and let's make a dest buffer as well. I do like that new hardware is like this, and they haven't managed to like obfuscate pointers like crazy, and they just give you, well, okay, RAM starts at 0, and then you count up. Kind of love that. All right. Oops, typo. I was like, what? Malloc reassignment the same buffer. And free shit. Let's go. Kernel print. Ooh, what do we have? TTT print. No, that's not what I want. Wait, I can print from kernels? That's kind of cool. Does that work? I ran. Wow, look at that terrible looking macro. Deprint. What are the odds this is gonna work? It didn't work. Maybe I have to like deprint cores. Oh, I ran. Cool. Wow, that's actually cool. Good work, Tenstorrent. That shit never works on GPUs. Like, I feel like it's supposed to work, but then like, you know. Great. So that's being printed by the kernel. Made some buffers. Let's try to read from the buffers. Let's see if we can read from the 2 buffers and then like have them add 2 numbers, and we'll see if we can saturate the bandwidth. Okay, well, we're gonna have to somehow tell it that it's what even are those numbers? Can we? Why do I need L1? Okay, I see. So I have to create an L1 buffer too. Wow, that's a lot of L1. Same, except let's just make my L1 that big. L1. Alright, L1 buffer address. Wait, like, is this like real? Can I just like look at these not coordinates and they're all actually the same? Programming model like CUDA, well, one of the really cool things that you see right away is this core range. Like CUDA doesn't have anything like this. CUDA will not let you put certain programs on certain cores. I wish they did, but they don't. Even though it should be able to. Like the GPU in theory should be able to, like, I should be able to use my compute units independently, but their schedulers are not great. Okay, what? Oh, why did I put a B? Alright, are these not coordinates like real? Let's see. LU? You want a LU? I hate. Can you put Tenstorrent? Can you make this in Python? Some of us really hate coding in C, you know? the stream has to be done by the time it's, you know, dinner. All right, well, they're all on 1, 0, so I'm not going to waste a lot of resources passing those in. All right, we're going to have to pass in some buffers. Let's put in less runtime args. You have to make it generic. What if someone's running on Wormhole 72 edition? Blah, 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 blah. This is also boring. You know what I need? I need Copilot. This is actually the kind of shit that it would help with. One of those crappy AI coding assistants. You know, normally I hate those things because I don't code in such verbose languages, but this is insane. Who codes in C? Python coming up? All right, sweet. Yeah, this should be in Python. That'd be sweet. All right, let's set the runtime args. Fucking namespace. All right. DRAM copy kernel ID. We just called it kernel ID. Program kernel ID core. Why do I have to pass the core to runtime args and create kernel? I guess fine, whatever. Why are none of those green? Expected a semicolon. No. Alright, great. L1 buffer. Yeah. All right. Printing from kernel. Buffer address. Who has time to type all this? Alright, great. We got the arguments. Wouldn't it be cool if they could be like passed in as like actual arguments? No, it's too much to ask for. Alright. Not wasting my time with that. We know that it's just 1, 0. But George, one time it's not going to be 1, 0, and you're going to be upset. Yeah, I'm aware. Alright, great. Verbose garbage. Alright. Knock. I'm actually kind of curious. Can I print that? Let's see what this actually is. Minecraft modding tutorial, that's right. Let's see. Alright, well, that'd be cool if it had like some like spaces. Can it print in hex? Or does it only print in numbers? Numbers are sad. Direct printing is supported for deep printing includes macros. Hex! Alright, let's get some hex. Alright, well, once you get the knock address. Oh, I see. It just like shifted some shit. Alright, great. Well, I'm glad we did that. Alright, we have to get these ones from the knock. Let's get the dest DRAM knock from dest DRAM. And then I don't know. Let's try like that. Brutal. All right, we're gonna read it into what? That's the parameter? That's the one that gets it? This is dest and this is source? Who wrote this? Why would you do that? Did I do it backwards? You're reading from this into that? Where is this defined? Source dest size. Oh! Oh! Why would you do that? Why would anyone write that? Mem copy. Dest source size, not source dest size. Dest ram knock. Knock async right there. Alright, let's go. Does this work? Cool. Let's see if it actually does something. I actually want to read these both. I do this. We're gonna have to give it double EL1. Let's do pointer arithmetic. Close that. Oh, what is page size and why does it matter? Point arithmetic? Ooh, can I put the read barrier at the end of both of them? Oh, that'd be based. Let's go. No, I plussed it. I did plus, and I made that the size. Wait, no, I just broke something. Wait, how come I can't plus it like that? I made the size that. Oh, no, I broke it. tt-smi-tr0? What's tr? I mean, it's r. Uh-oh. Now it's not allocating anymore. We broke it. But I don't understand why it doesn't work though. I allocated that. I mean, I guess I didn't assert to see if the allocation failed. What do you mean? No, I did that. No, it's always just 1 and 0. It's never not 1 and 0. That's not the problem. Where is this hanging now? Boys, I broke the Tenstorrent card. I should reset the board. I am resetting the board. I broke it. Uh-oh, it's getting hot. What do you mean? I am constructing a knock address from that. That's what these zeros and ones are. It works fine. At least this computer reboots fast. Hopefully. Now let's really power cycle it. Should we really power cycle it? I don't know if reboot's gonna work. But I don't understand why my plus 100, plus 1,000 didn't work. Yeah, or hard power cycling the computer. It is blasphemy in the ML world, you're right. You only have have two nonce. It's not like it's going to come up with a lot of different things. I'm not passing in all those arguments. That would involve so much typing. For which cases is a CS degree useful? It's useful for getting non-subscribers banned from talking. Alright, we're back. Tenstorrent, tt-twitch. Okay, that's not very big card this time. tt-smi. Can I print L1 address? Yeah, I can. Reconnecting Q. Why isn't this working? Whatever. FF00. And I'll put the size back to that. Still FF00. And I'll put the page size up. I don't really know what the page size does. Oh, now we got something different. Oh no, FE00. Oh, I see. So is that like size and byte, size of unit being interleaved for non. Oh, don't interleave your buffers. Oh, good. I knew I wasn't supposed to interleave my buffers. Wait, but that should be okay with EE00, right? That's fine. It was just my page size that was wrong because they were like supposedly interleaved or something. That should be fine, right? Yeah, YOLO. It's fine. It's gotta be fine. Because that's FF and that's, yeah, okay. Any L1 address should be larger than, that seems okay, right? Yeah, we're good. No, we're good, we're good, we're good. We're good. I know it wrapped around, but it was just because I didn't set my page size correctly. But now that I set my page size correctly, let's just call this progress. I'm going to create a quick GitHub new repo for this. Repository name, tt-twitch, Tenstorrent, kernel from Twitch. Public, great, create repository. Oh, remote denied. There you go. Anyone who wants to play. What do you mean make a PR directly? No, it's fine. Okay, this is all well and good, but now I want to like, let's say I want to like add things. So, that's stupid. Let's look at some demos. So this is fine for like data movement and stuff, but it doesn't show me how to actually access data. Let's go back There we go. Element wise, what's SFPU? Sundance Flash Programming Utility. Oh. Never heard of that acronym before. Yeah. I'm doing an ad. That's what I'm doing. All right. Let's look at the examples in TT Metal. Not that. That's examples. Element one is binary. Okay. Host creates two. Wow, this looks complicated. Using circular buffers. What's a circular buffer? It's a FIFO in between kernels. Oh, I see. So they have like a B risk and C risk. Oh, I see. So it's got a reader and a writer. All right, let's just like not do it like that. Let's just let's start by just doing it in this kernel here. Okay, so how do I like? Can I just like read L? Can I like dereference L1? No, I don't need two kernels. I'm doing it in one kernel. I just read L1, so I can like dereference L1. So if I just were to do something like sick, I don't know. I designed this for just do these. I don't want to think about D types right now. Okay, so yeah. The math engine? I don't use the math engine. That sounds complicated. I'm using the plus. We'll get to the math engine later. Well. Invalid conversion. Invalid types for a subscript, you say? What? No, I don't. You're saying, oh, oops, no, sorry, you're right, I just forgot about, no, second, okay, fine. Oh, that's probably that F0? Oh, it stays in hex mode? Whatever. Let's copy in some A's. Oh, you know what I'd love to do right now? Listen to some copyrighted music. It's one of my favorite things to do on stream. Ooh, a play! That's my favorite place to eat crinkly candies. Q write buffer. Alright, well, let's DRAM buffer input vec. Oh, you got it. Vector. Input vec. Oh yeah, you want to see some elite C++, boys? C++ is so fast that you can just do things like this. Input vec dot, oh, what is it, push back? God, how does it encode in this language? Let's see if it says dat AA. No matching call. Oh. Does it have to be that? Whatever, DRAM's big. Buff page size. Buffer pages must fit within the command queue data center. Buffer.page size less than. I knew this page size was a scam. Oh, let's make them small. Is that gonna work? Sweet. Oh, look at that. Dat AA. Yeah. Yeah. Alright, I don't know. Let's do this math in 32 bits. Let's really flex this processor. Let's flex on him. Let's flex on this, but let's go. Is it big endian or little endian? Dat AA BBCC. All right, we ready to do math? Let's do math. In CUDA, this would be very fast. So let's try 1 plus 1. And then after we're done, we're going to read the buffer. How do I read the buffer? Does this work? NQ read buffer. I got to do it. Is that going to be the whole buffer? That's disgusting. All right, let's not add 1 and 1. Let's add 13 and 7. Let's give it something hard. All right. That crap. Oh, fuck C++. That's DRAM buffer. Doesn't fit. Well, I thought it was an output DRAM buffer. We don't have that. We have a desk DRAM buffer. Reading there. Read. Output. All right. I knew it couldn't do. I knew it couldn't do it. Oh no, we just forgot semicolon. That's fine. 21. What's 13 plus 7, guys? No. No, it's 20. I did put in 13 and 7, right? It's cheating at blackjack. No, what did I do? How did I even do that? I put 13 and 7. I put them in there, and then I got the result, and I added them in the kernel. No, sorry. My bad. I still don't know why that's 21. Oh, it's hex. Alright, never mind. Alright, we made multiple mistakes and they almost canceled out. There was a check somewhere at 20. Alright, look at that. Look at that. They're using Tenstorrent to add numbers. I knew it could add numbers, guys. Alright. Let's figure out how to use the math engine to add numbers fast. Where's Shanshi Magic Chicken? What chicken? Use Devin and he said 21. Guys, it's coded by 10 IMO gold medalists. I'm sure they know what 13 plus 7 is. Okay, now let's read about the math engine. My magic chicken, I forgot how far away it was, but it wasn't here. I do know that. $12 minutes until chicken time. Those are Uber minutes, so it's actually probably going to be more like 20. All right. You too can buy a Tenstorrent and add 13.7. Alright, can I make it big but make the page size small? Interleaved. Oh, no, don't do that. Segmentation fault. Don't do that. Oh, it might be the allocation that succeeds actually, but then it tries to copy from more of the vec than fits. That's actually probably right. Yeah, that's probably the problem. Yeah, okay, that's fine. Math engine works on 32 by 32 tiles, so we need to build float tiles. Oh god, why can't I just use CUDA? CUDA would just make this code fast. No, wait a second. Don't I have lots of cores? What if I use lots of cores to do this? Does that fix the problem? All right, let's read about the math engine. So first we're going to need circular buffers. Oh, this is for communication. This looks hard. Oh, cool. I can just make up whatever address I want. I love that. Ooh, we can control the math fidelity. Compute config. Oh, okay. Passing in some config already. Oh, data movement config. Alright, so let's read this whole thing. How does it know that this one's a... I see. So you have data movement configs, and you have... Why are these on different processors? What's a B risk and what's an NC risk? What do you mean it doesn't matter? Are they the same? Do I have to put one on one and one on the other? Basically, yes. Okay, great. I see. So this program's creating kernels to... I only need one data movement kernel? Why does this one have two? It's optimized. What if I have no data movement kernels? And what if I just put the compute in the data? Okay, I see. What's this? Let's read this. Low-level kernels. Oh, okay. All right, these are good. Wait. Kernel APIs. Oh, okay. This is understandable. Circular buffer. Like a ring? Why isn't it called a ring buffer? Compute kernels have access to the math engine, but they don't have access to RAM. And it just depends on, and it knows what kind of kernel it is based on what like config I pass in here. I see. Okay, data movement config, compute config, Ethernet config. I see. But like I can still like both cores have the same. Yeah, no, I get that. But like so each core has a compute and data transfer kernel. I see. Oh, I see. So actually on each core I have two RISC processors. And I can put the data on, I see, I understand. So like I put the data on one of them or the other one. But they're all still on core 0,0, and I actually have 120 of these cores. Am I understanding this right? Each core has 5. All right, cool. What are the other ones? Oh, stupid thing with the commas. 2 run data kernels, 3 cores run the compute kernel, I say. Place my content. Oh. Loading scene. It's loading. Wait, so can I create 3 compute kernels? Or is it the same compute kernel that just runs on the 3 cores automatically? Three RISC-V on 1 compute automatically. Wait, where's my picture? I don't get a picture. SRAM DM kernel RISC-V circular buffer goes to compute. Okay, I understand this. Yeah, this is fine. And so basically these 5, I don't exactly understand why the compute is 3 separate processors. Maybe I'll try it in incognito. It'll work. Let's just put that state. Don't know. Missing W? Missing a W at the end? Ah. I see. Cool. W? Oh, I see. I didn't. Okay, never mind. My bad. Oh, okay, so this is knock 0 and knock 1. The compute kernels are automatically multiple for some reason. Seems reasonable, I guess. I see. So these are just, yeah, they're just circular buffers inside the thing. I mean, this is a lot smarter. You see why this is better than GPUs. GPUs use the same stupid instruction stream for the it's so annoying in tinygrad that it uses the same basic ALU to compute all the data addresses. Yeah, this is what you want. Oh, cool. Yeah, very understandable. Yeah, look, there's a lot of things on here that are better than GPUs. It's just, you know, underpowered right now. Well, actually, are both data movement kernels, like, can I use them both to read? Because that's what you want to do most of the time. Yeah, okay, good. Like, most things you're doing are basically reading from, like, weights and, yeah. I mean, I'm curious how this stuff's implemented. So, like, can I read the implementation of, like, I want to read the implementation of, like, knock async read. Where is that written? Where's the code for that? Well, in Dataflow, oh, here, look at knock async read 1 packet. Oh, okay, here we go, cool. Oh, great. Oh, I'm glad this stuff's open source. Good. You'll do far better if this kind of stuff's open source, because it really bothers me when it just, like, links to some stupid thing because for some reason they don't want to show off their MMIO. And yeah. All right, cool. So it's just poking some MMIO. That's very reasonable. Yeah, it's a deal, man. Read any len is just some wrapper. Yeah, that's cool. Now, how flexible is it? Just linear? I mean, I guess if I have a whole processor, it's not that big of a deal. There's some things here that's way ahead of GPUs. Alright, these are the compute APIs, so let's find those. Hardware Inc. Let's see what's in that folder. Oh, okay, so it's custom for Grayskull. You just leave data shared in L1 between kernels. I don't really follow that. What's this compute stuff? Volatiles in it? LLK. What's an LLK? Oh, this looks complicated. It's much more complicated than the DMA engine. Grayskull Metal LLK API. Wow, this looks complicated. Why did that link me to wormhole? How did I end up in wormhole? The wrong one. It linked the wrong one. Let's see. So, is there any stuff about how, like, this is running on 3 RISC processors? What's the actual code that's being broken down to the no, no, I know this. This is not, obviously. But no, I'm curious how it actually talks to how, like, the 3, I'm interested in the 3 compute engines, because this is something I don't understand. Like, there's 3 of them. Are they running the same code? Task splitting? Is like a thing I can Google somewhere? I've never heard of that. But, like, that doesn't really make sense to me. They're running the same, like, instruction code. Like, so I see that I can dispatch 3 kernels to the same core, but these 3 are just like, some of them only listen to some. Are there any docs on this? Or there's 3 different programs. Low-level kernels. Below is a simple example of SFPI is a programming interface to the SFPU. Consists of a C++ wrapper wrapped around a blah 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 to generate SFPU instructions. Okay, so it's an extended instruction set, which is fine. I can see that here. It's not done with MMIO, which I guess would kind of be unreasonable for compute. T-risk. No, I mean, I get this. I think. Alright, you have a different kind of MATML engine for both of them. That's fine. ALUI. No, but can I dump the programs? Well, I guess this isn't really compiling 3 programs. I guess I need to compile a compute kernel if I wanna see what's going on. Like, I'm trying to understand. This code is identical for the 3? I don't know. Maybe it's magic chicken time, and then we're going to figure out how to compile a compute kernel. We're going to figure out how to dump the RISC code. It's not magic chicken time. No,
this is making me quite bullish on Tenstorrent, guys. Like,
this file. Okay. Oh, I'm wearing sweatpants. That's the kind of morning it is. I woke up early for this stream, boys. Okay, let's write a look at matmul tiles. Oh, I see. Okay, there's unpack, pack. Okay, no. I think you're okay. I think I know what I'm looking for. So it's the yeah. I get it. Okay. Yeah. Okay. Good. Totally understand what's going on. Yeah, so it actually is just compiling 3 separate binaries. So there's 5 binaries, pack, math. So I guess they share registers. Oh, we can get into the low levels of this and it'd be fun, but 3-way, 2-way dispatch. I mean, this gets into CPU stuff, I don't know. What? They pushed my chicken. DM kernels are 1-to-1. Okay. Compute kernels are 1-to-3. Okay. Yeah, I understand. Cool. So let me just read that binary. I guess the last thing I'm not really understanding is how they're being dispatched, but this should be pretty easy to just understand. Okay, so here we create the kernel, we create, this is a good example. Let me just build this example. Spin up my whole thing. Why that requires. Whatever. Okay, so we create 3 kernels. A reader, a writer, because we're creating a new program, we must redeclare all the circular buffers. Don't exactly understand. Oh, I guess circular buffers are created for some reason on the program. There were good docs somewhere. Where did those good docs go? Create a circular buffer in element memory for all cores within core ranges inclusive and adds it to the program. Create a total of 32 circular buffers per core. If a config is specified by the circular buffer address space is shared, how does that work? Yeah, okay. So create kernel, set your runtime args on the kernel. Oh, I see. Okay, so a program can have multiple kernels bound to it based on, okay. This is sensible. I now understand. Sorry for saying that I was making fun of the OpenCL. The OpenCL API has a concept of programs and kernels, and it's the stupidest concept. Like, I don't know who wrote that in the OpenCL API, but it's nonsensical there. I thought this was just copying that, but no, this actually makes a lot of sense. Okay, so you create a program. Program is multiple kernels. Create my 3 kernels. Bind them all to the program. Write stuff to the thing. All right, I think that actually finished. Let's see if it works. Okay. Great. Yeah, programs have 120 different kernels. I understand that. No, I mean, that's a huge... Like, GPUs basically have the same thing. So, like, if you look at, like, the 7900 XTX, they have these things called compute units, but the scheduler is a global scheduler. And it's annoying... NVIDIA is pushing away from this now with some of the H100 stuff. I haven't played with it that much. But, yeah, I mean, what you really want to do is you want to have kernels that are, like, dedicated to different things. You want to have some kernels handle memory, some kernels handle math. It's rare that you want them to be the same. But so this is interesting that it actually just sticks all the cores on one. And I knew this. This was presented to me a while ago, but it's cool to actually see it. Okay. Unfortunately, this API is hella verbose. I could write such a sick Python API for this. Oh, like imagine a sick Python API where it's just like you pass it in 3 strings and it just gives you the program. Where's my chicken? Said it was here. Said it was close. Magic chicken, magic chicken. Recently tried to contact me. Oh. I want to go outside. I'll figure it out. Oh, I hear steps. Someone's checking that. Num tiles 1. What are tiles? I guess we'll know if we look at this program. Tiles. So this knock X and knock Y. Is this always 1 and 0? Like how much can those vary? Like what are those? Are there only 2 knocks? I thought there were 2 knocks. Chicken! Oh, you guys are ready to experience Shanxi magic chicken. Have 8 banks on GS. Oh, I understand. Yeah. Can you see the chicken? It's chicken eating time. You can't see the chicken. Oh, the chicken. I love this chicken. So it comes with these big, flat, like hand pull. You know those like hand cut noodles, kind of where the guy does it with like a knife and like cuts them apart. All right. If eating offends you, and this isn't Japan, so I can stick my chopsticks in like that. Ooh. GS sock. Oh, Grayskull, I assume. Oh, when you say GS, you mean Grayskull. Okay. Worker cores, 8 DRAM. Oh, I get it. That's the 1,0. It's right there. 1,0 is right there. That's why we got 1,0. Oh, that makes a lot of sense. Cool. So I see. I have to do the addresses. I understand too. It's probably like, I mean, the RAMs are actually each, like, it's 8 different RAMs, like, completely. Oh. Is that what interleaving is? I mean, because really what you want to do to, like, maximize bandwidth is you don't want to put the whole buffer in one thing. You want to share your buffer across all 8. Do the pages. Okay, that's sensible. I would not expect there to be a read barrier there. Oh, we're just to half do that. Okay, never mind. File an issue for one of your requests. My beautiful Python API? Oh, yeah. Yeah, it's just how memcopy is. Okay. Pack, math, unpack. Well, they're so explicit about data movement. 1 core to do math, 4 cores to move data. I really want to zoom out here, get the big chicken picture here. Are we liking the chicken eating part of the stream? We'll even let non-subs talk during the chicken part. Contours on replacing. No one's getting replaced by AI, man. Where's the Marvin Minsky 1970 article replaced AI? Here we go. Yes, Marvin Minsky. Can I find the actual? Can I find the actual Life magazine article? No, there's like an article. I saw it. I want the full article. The full article is hilarious to read. He was not misquoted. I've read the whole article. Oh, here we go. Can I see that page? The internet has too many ads. All right, we got a slightly longer quote from the article. Here we go. This is from Life magazine in 1970. So we're talking 55 years ago. Marvin Minsky of MIT's Project Mat recently told me, in from 3 to 8 years, 1973 to 1978, we will have a machine with the general intelligence of an average human being. I mean a machine that will be able to read Shakespeare, grease a car, play office politics, tell a joke, have a fight. At that point, the machine will begin to educate itself with fantastic speed. In a few months, it will be at a genius level, and a few months after that, its powers will be incalculable. 1970, okay? So, for every little fuck out there who tells you, but I saw ChatGPT and ChatGPT. I think that all jobs are going to be replaced in 3 years. They're not. And Minsky was friends with Epstein. I don't know. Look, I'm not going to hate on Marvin Minsky. A lot of people have thought this kind of stuff. And also, in 1970, it was more excusable for you to believe it. Like, if the year was 1970, you didn't know better. This year, you should know better. AI is cool. Computers are cool. Computers can do a lot of stuff. Computers are going to be able to do more stuff. All jobs are not going to be replaced in a few years. I mean, it's like doomer shit. It is. It is. And then the worst part is, like, Marvin Minsky, at least, was not a doomer. He was an optimist about this stuff. I mean, it kind of would be cool if that was going to happen, but it's not. What about driving? I mean, you've seen the progress. There's some progress. It's okay. I'm working on it. Tesla's working on it. When can we replace tech bros? I mean, if you consider me a tech bro, never. Like, people like me are actually probably the last people to be replaced. Except maybe for... There'll be some guys who want hookers that are genuine humans. And there's some people who want, like, a genuine human to suffer. And those jobs will never be replaced. People who want the real thing, not just a facsimile. No, you don't understand. It's not about my enjoyment. It's about their suffering. You want an AI girlfriend? You can have one today. They're just not very good. I mean, for some guys, it's probably better than what they can get, but not for most. Yeah, read a Casino Odyssey. Are you trying to open the door? Would you like to come in? You want some Shang-Chi magic chicken? We're on stream.
I come back for sushi later.
Oh, I'm sushi tonight.
Don't worry.
I shouldn't eat all the magic chicken.
Don't spoil your appetite.
I had acai bowl this morning too.
I can drink my juice, thank you.
Enjoy.
Omakase.
Omakase. Do it later. What do I think of Beth's chip? I think quantum stuff has a long way to go to be useful. There have been a lot of quantum startups, and what you end up finding usually is that they can solve the problem, but the problem isn't exactly what you wanted to begin with. D-Wave... I don't know. I mean, you know I'm bearish on quantum in general. I think that P equals BQP. So I think that anything you could do with a quantum computer fast, you can do with a classical computer fast. You just need better software. Is this hardware similar to Groq? Groq looks a lot more like a TPU. No, this is something entirely different. And one cool thing about Tenstorrent is like they're thinking about the future beyond the current training paradigm. I'm not bullish on Groq. Again, if Groq had a card that I could buy for $800 in an open source API, I might be. But they don't. They're trying this stupid like enterprise sale. Can I buy a Groq card? Can I buy a Groq card without contact us? And is any of their stuff open source? Get in touch. No. Oh, buy on Mouser. Okay, hang on. $20,000. Yeah. I mean, they do have one, but it's $20,000. Also, is their code open source? What do I get if I buy this thing? The official Python. Oh God. No, this is like OpenAI level shit. Okay, here we go. Groqflow is the easiest way to get started. Automated compiler. What's in here? Do they document their chip anywhere? I'll take back my hate for Groq when they document their chip and they charge a reasonable price for it. But until then, Well, I mean, Tenstorrent is the newer paradigm. So we know that the brain doesn't do background. Like the brain, regardless of what scale you want to do it at, like you're going to have to break things down to smaller work units. NVIDIA has pushed so hard on having a full fabric memory. Like NVIDIA has 900 gigabyte per second across a data center. This is insane. I mean, it's incredible engineering, but it's not the future of neural networks. Like NVIDIA has gone so much out of their way to make it easy for the software guys. And this is why they're crushing it right now. Oh, you've heard about Thought Complex 7. Oh, we're going to build Thought Complex 7. AI hardware companies are not as much of a scam as other industries. I mean, some of them are. Again, you want to figure out if something's a scam or not, can you buy anything from them? If you can't buy anything from them, it's probably a scam. Or too early. Might be too early, but probably a scam. Contact us, scam. All they say when they're doing contact us is, we know that we're not competitive in the market, but let our sales guy try to talk you into it anyway. So, can't you buy this? Oh. No, I know you can buy. Yeah, I mean, you can buy Grayskull now. That's the only reason I'm talking about it. Wait, why is it still that? Oh, that's just a bug. You should fix that link. No, the only reason that I'm here doing this is because Grayskull is openly available on the market. I do not care about anything that other people can't participate in. I paid my own $800 for it. Yeah, so Wormhole didn't look that much better. Wait, what? Oh. Like, it's still 12 nanometer. It is cool that it has the link. I mean, that seems to be the big advantage of Wormhole. I mean, I don't know. If I were Tenstorrent, I'd switch to tinygrad. And make the simplest, most beautiful API to expose like what I was playing with today. There's so much unnecessary complexity built on top of like what's really a pretty simple compute paradigm. Because it's just unsustainable to do it a different way. Like, if you don't have something, I mean, you don't have to necessarily use tinygrad, but if you don't have something that looks like tinygrad, you're never going to be able to keep up with the state-of-the-art machine learning. Because the problem is, like, NVIDIA doesn't have to keep up. NVIDIA, by being the state-of-the-art, can just, everyone ports to NVIDIA anyway. Everyone designs for NVIDIA. AMD has an interesting follower strategy where their card is similar enough to NVIDIA that people will choose it just based on price. The MI300X, I saw Microsoft got them for 10 grand. Like, you're paying, it's half off an H100 basically, more than half off. And at that sort of price break, people will tolerate some amount of annoyance in the software, but not much. But only because the two GPUs, the MI300X and the H100 are so similar that that AMD can be competitive. If you're trying a different paradigm thing, you are never going to be able to build something that looks like Buda. Because you won't keep up with the state-of-the-art machine learning. Like, you need something that transpiles to like a much sort of better intermediary. I don't know what neuromorphic computing is, and I don't think it has any meaning. I think that Tenstorrent looks a whole lot more like a neocortex. I mean, like, Groq and TPUs have taken a completely... This does look kind of like a GPU. It's a GPU with a better scheduler and better control, but like GPUs are going to... we're going to kind of see emerge. The H100 already has a lot of these sort of like Tenstorrent looking features. Like look up the Tensor... it's a TMA, it's a Tensor Math engine. It's like a fancy... It's a fancy DMA engine, but it kind of can replace the load kernel. But you could even have like a straight up load kernel. Like what Tenstorrent's doing with the RISC-V, that totally works too. It might even be better. Also having like a grid architecture like this, you're going to need a grid architecture at some scale So why not start that scale smaller? You know, we're pretty booked for the rest of the year, but after the year is up, if you'd like to contract the Tiny Corp to build a cleaner, more functional port than yours, we can do it. I'm interested in building some of this stuff generically anyway. I'm interested in building so here's kind of what I'm saying. The thing you call the graph compiler should be generic. I mean a port that runs tinygrad on Grayskull in a wormhole. And I think I can beat most of your examples. I mean, like, it's not only could I beat the examples, like you saw me try to use Buda and you saw me try to do something that like looked obvious and it didn't work. But it's not even just that. The problem comes down to there'll be new ops added in deep learning. People think like attention is this, oh, we're gonna have attention forever. We're not. In 5 years, people are gonna be like, oh yeah, attention, that was cool. That was like early 20s AI. Well, no, again, I'm an overpaid contractor, and actually what I would rather you do, instead of paying TinyCorp, what I would rather you do is port it yourself to tinygrad. Focus on building a beautiful Python abstraction for as low level as you could possibly get. I think your kernels, like I can see the Python abstraction already. Look, I'm too lazy right now. Where to plug in? You want to plug in at that layer that I'm playing with now. You don't need you don't have to go to the MMIO layer. You don't need to make a RISC-V compiler. Don't do any of that stuff. But you're gonna want to. Have tinygrad emit the kernels. You're going to need to make some changes to the linearizer. So right now the linearizer emits one UOP stream, and this one UOP stream includes loads, compute, and stores all in the same stream. But it would be like a 10-line change to emit the loads, computes, and stores to 3 different kernels. And then you're going to want to write a runtime for Tenstorrent, and this runtime for Tenstorrent should wrap your C++ API. So if you have a stable C++ API, you should just wrap that with Python such that it's like a simple, like, here's my kernel, here's my source code. Yeah, and then like the things should map pretty well. Like you can definitely deal with like DRAM and L1, like that all works in like the shapes. Yeah, use tinygrad to emit the C++ kernels directly, absolutely. Again, it's not that different from what you already have. You'll have to write a renderer. You'll have to make a change to linearizer to split the UOP stream for loads. In like loads, and you use like those circular buffers and the queues. Yeah, I know you don't emit the kernels. And I think that this is exactly what I'm talking about will never scale. If you're pre-writing the kernels, like you'll never be competitive with, no, I understand. I read briefly what Buda was, but if you're doing that, you're never going to be competitive with NVIDIA. Because there's always going to be new ops and you're always going to be behind. Versus like, yeah, tinygrad can emit the kernels for you. Again, for less money in the contract, I can get a functional tinygrad port. There's like a functional tinygrad port, and then there's a fast tinygrad port. You should be able to have something functional. And then The minute you get tinygrad functional, all of our examples work, including training. Like we now have ResNet. We now have ResNet 50 training on a tinybox. We'll have all of MLPerf by the end of the year. But yeah, no, omit the kernels. Definitely omit the kernels. Like that layer I'm playing with is the right layer. No, I'm not using the layer. Oh, I mean, it'll, like, for perf, what you want to get working, no. See, that's the joke, right? So don't optimize your kernel generation. Figure out how to parameterize your kernel generation and then use search. So it is one of my favorite documents, a bitter lesson. Like, read this document, stop trying to hand optimize things and figure out how to parameterize them and use machines to search. Yeah, so tinygrad has an option called beam. And this is how we're now beating Torch. We're better than Torch on M1 and on AMD, but only if you do a big beam search. Which will just search, 1,000 permutations of the kernel that are all correct and just figure out which one's the fastest. Computer go burr, there we go. Also, don't prematurely optimize. I mean, this is just classic. Like, it's not like your wormhole chip is ever going to be, your Grayskull chip is ever going to be fast. No. I don't want. So here, I can show you in tinygrad how the. If you have like a matmul kernel thing, the tinygrad cogen can deal with that. If you have something that looks like a whammy. So here are the tensor cores. Like the tensor cores are all just specified right here. So like I think you have like 32 by 32 by 32s. Whatever you have, you can just specify it here. Yeah, it's really easy. Like this, we have working we have all three of the tensor cores working: the AMD ones, the nvidia ones, and the Metal ones. Yeah. Okay. So you want to turn the chip into a systolic array. I wouldn't worry about that. I see. Like, in each one of your cores, you have something that looks like a. What you're talking about there is not. What you're talking about there is like what's called like locals in a GPU. So GPUs have like warps, but I think each one of your cores is an entire warp because your cores look more like a compute unit on a GPU. So your core is a warp, and then you have locals on top of that. And your locals can have a grid, and yeah, you can just, like, don't worry about the idea of, like, we're making this a systolic array for multiplication. Worry about saying, if this core is trying to load data that this core already has, just fetch it there. Right? You write that primitive, and then that primitive scales to the entire chip, instead of trying to, like, plan the entire chip. everything in tinygrad is 100% static, meaning meaning you can pre-compute all the memory accesses. All right, we're done with chicken now. Okay, I think we're gonna put chicken in the fridge. We're gonna get a little bit of coffee, and then should we start writing the runtime? Like, it'll be beautiful. All right. We'll write a little bit of runtime. We'll get some kernels working from Python, and then we'll call it for a stream. Thank you. We'll see if C types can generate C++ garbage. Actually, let me take a 5-minute break. I'll be back. Oh, hey. What I didn't really say about the systolic array thing was don't worry about speed, worry about correctness. What I found, so now tinygrad is speed competitive on Apple and AMD compared to Torch. The speed of tinygrad at the beginning was completely non-existent. We focused on correctness. And I think you can always get speed later just by like adding tweaks to make things more correct. Again, there's nothing in tinygrad that's fundamentally slow. It's incredibly flexible and can generate, I mean, it generates all the kernels, right? Like if you write like if you lock yourself into like a matmul kernel that's slow, sure, it'll never be fast. But there's nothing fundamental in tinygrad that's slow. And we can always add, you know, after careful consideration, new abstractions if you need them, but I actually don't think you do. So let's look a little bit at what I think the right layer of abstraction is for the card. What? You like detecting a thumbs up? What the hell is this? Is this an AI? Do you guys see a thumbs up? Like you're detecting, what is this? Some like AI detecting a thumbs up? That's creepy. AI's creepy. All right. Okay. So, let's take a look at what that's a Mac camera feature? Weird. So let's take a look at what the tinygrad abstraction is. So we have a compiler, a program, and an allocator, and a device. So we're gonna, like, this is, by the way, this is the whole abstraction. Like, you can read this. This is all the code you need for Metal in tinygrad. So what would it take to transform Tenstorrent to be similar? So let's write example.py. So we're going to have something like, just write out a compile function. So our compiler is going to take in source RISC0. Let's try to re-implement the element-wise thing, but in Python and in like a readable way. Let's implement alloc. So yeah, there's 3 kernels. There's RISC0, RISC1. And let's also get that magic TT metal home. So we have source RISC1. By the way, did I put mine on RISC1 or did I put mine on that's my kernel. Where's my main? I put mine on RISC0, so I guess it doesn't really matter. Is the ISA documented? Sort of. I mean, all the stuff you, maybe the firmware is not open source, but all the stuff you basically want to see is open source. And the schedule is explicit. So like we have like source RISC1. Actually, let's not call them RISC. Let's call them data. Source compute. Also, does this one allocate any L1? So I found it weird kind of that it could allocate L1. You don't really want to do that. You want to like use the circular buffers, I think. I think that, yeah, sure, or maybe you can like use the L1 for long-standing kernel stuff and keep it allocated. I guess that's the point of it. But I don't know why you want to do that. Yeah, I can keep tensors. I mean, some day. Sharding your tensors across the whole thing, you keep them resident in L1. Yeah, that's cool. I see. So yeah, no, you sharded across all the cores. I guess what I don't understand about that is when I allocate this L1, is this on every core? On every core, okay. So this size is actually times 120. Well, times interleave, but where do I specify interleave? How is it sharded on core range? I create the buffer long before I specify a core range. Interleaved. The DRAM is interleaved too? And then also another idea I had was, so all of these kernels, unless there's some reason you can't do this, all of these kernels pass in the address, the source, the knock X, and then call this get knock address. But why don't I just do this in, why don't I just do this in, why don't I do that in C++ and then pass the real address in here? Instead of passing, I guess, do the args have to be uint32s? Why don't I just pass in the uint64 knock address and then like compute that beforehand and not at compile time? Okay. So circular buffers very notably apply to the program. So you'd want to specify your circular buffer stuff here at compile time. I don't know if processor knock ever. Yeah. Compute inputs, data flow in out, compute outputs. I mean, I could, like, I'm okay also with being like opinionated in the API and doing something like that. And then so a allocator in tinygrad has, it also has copy in and copy out. Notice my use of destined source. So these are opaque pointers. Remember the one where it was just specifying like addresses for the circular buffers? Oh, it has to be a vector 32. Don't need to specify any address for CBs. What's a CB? Oh, I see. Yeah. There were other things that there was one other example I saw that maybe it was this one. No, I don't know where it went. There were ones that just put an address in for the circular buffer, but yeah, it didn't make sense. Create a circular buffer within the core. So I guess I'm a little confused about that, but this is how kernels can use interleave buffers just via address. I don't know about that. Blah, blah, blah. Then we're gonna have something like compute options. I see that being passed around a lot here. Compute config. It hides the DRAM. Okay. Yeah, I mean, this might be beyond like a reasonably doing this stream. But yeah, I mean, these abstractions are quite good. Like if you just, this isn't even like the metal one is pretty complicated. Like the Python one is pretty minimal. This is like a compiler, an allocator, and a device. Oh, the Clang one's super tiny. There's so much crap in C++. Start with something simple like a write buffer. Let's figure out what library actually contains this. Okay, tt-metal. Oh, I know where it is. It's in build lib. So we have a thing in tinygrad called origin stubs. We'll see how well it's going to work. Every time I do this, I always have to fix bugs in this thing. Let's take a look at this host API. Well, hang on. Can I access this stuff? Is this accessible through tt-lib? I mean, tt-lib was a pain in the ass to install anyway, though. There are Python APIs for some of these. How many? Like, can I rewrite this example in Python? Is there anything missing? I mean, like, you really want your Python to be auto-generated from your C and not compiled. And then recompile ttnn? No way, I'm out. All right. Ban anyone who mentions Devin. Okay. I don't know how to do that, but if we have any mods, do that. I can't believe you guys fall for that, you guys. I'm gonna make a AI called Karen, okay? And you know what Karen does? She goes to the DMV and stands in front of you in line and just complains about stuff, and you're like, Karen, we have things to do, and then she screams at you. And you're gonna be like, wow, that's amazing! AI's gonna replace so many people's jobs! Right? Like, don't you want somebody to, like, you know, when you're hanging out with your friends, you're like, bro, it's fucking retarded, and Karen goes, you can't say retarded, there's actual people with mental retardation, or you're upsetting! Right? Like, we can make AI do that. Think about that. Think about that, right? Devin is only for VCs. See, the thing about VCs, and the thing about, like, you ask yourself, like, why is the deep state so bad right now? Like, why is the deep state so much deep stating? And it's because they're losing their grasp on power, and they know it. And so are VCs. Who respects VCs? Haven't seen Ilya. I love those Ilya milk cartons. You know, poor guy. I don't know. Like, this is what happens when you get involved with utilitarians, man. Utilitarians eventually turn against you. That's the only way utilitarian ends. Eventually, you think you're friends with the utilitarian, but eventually they will decide if there is more utility in you dying. Oh man, who triggered me? You triggered me with Devin. Oh my god. And like, you're giving them press. Like, you know, he's not even a bad guy. Like I don't even, like, I saw the people, they didn't even look like bad people. But like, it's the stupidest hype I've ever seen. Ask yourself, would you be impressed if a human did it, right? Like replace Devin with Kumar, okay? And his name's Kumar, and, you know, not to be stereotypical, but he cheated his way through everything, and he managed to solve 13.6% of issues on GitHub, right? Like, no, just stop. Like, replace AI with people. And if you're not impressed when a people does it, why should you be impressed by AI does it? You want impressive AI? AlphaGo. Like, that shit's impressive, man. It beats everybody at Go. That's cool. A software engineer that solves... Imagine we have a car that, you know, only doesn't crash 13.6% of the time. Right? Like, oh my god, no. Like, guys, we just have to exclude VCs from polite society. Okay? What has ever come that was VC funded that was good? And like, Uber was good. Yeah, Uber would have existed with or without VC funding, and the version without VC funding would have been better. Airbnb was good. No, it wasn't. Craigslist was better. What did Founders Fund from Teal make? What do any of these things make? Founders Fund from Teal made like Palantir and Anduril. Things that don't help you. Though, you know, it is good to know that Palmer Lucky's on our side. And it's not going to be, you know, it's not going to be the F-35. I was thinking last night, like an F-35 costs $100 million. Which would you rather? One F-35 or 10,000 DJI drones with grenades? Like, remember how the birds, do you remember the time the birds took down that plane and it landed in the Hudson? Like, imagine the birds are drones. .gmc, I can't believe you're a subscriber. Who gave you money? I know DJI is Chinese. Look. I'm going to show you guys a video. Yeah, have you seen these things? Better one now. This one. This is the Chinese military-industrial complex. Okay? Yeah, okay? So I'm just saying. Alright. Where were we? We were trying to get this shit to compile. I'm going to end up rewriting this thing. I know I'm going to end up rewriting this thing. I'm sorry if you were trying to sleep. You all got an ad for the Chinese military-industrial complex. Why are those... Why is true? Oh. Yeah, I mean, we're gonna lose. Of course we're gonna lose. They're not even trying, you guys. You don't understand. America was a country built on slavery. We deserve to lose the Chinese. Look, it depends what you mean by America. No, there's really, like, I think it's really, like, getting to a head where you have to take money away from these people, right? And it's the same people. It's the VCs, the deep state, the government. The problem is they own the money printer and they're friends with the guy who owns the money printer, right? And you think crypto's better? Who owns that money printer, right? Like this will not be solved until we go back to gold. This is the only way to fix this. Like everybody needs to stop accepting the fake paper money or the fake shitcoins too. It's not better. Crypto is the same thing. Oh, but there's only 21 million of them. There's not. Right? That's not a naturally defined thing. It's just defined in some source code somewhere. Defined 21 million. But no, they would never raise the limit. They will raise the limit. I promise they will raise the limit. You know what they can't raise the limit of? Gold. Like, money needs to be based on something that is naturally scarce, or you will always end up in the shit that we're in today. Like it's really getting to a head now. Well, you can try to make more gold. Good luck. Like, the only way that this stuff gets fixed, that all the scams get fixed, that everything becomes like we have been stagnant since then. Yeah, gold and asteroids. Gold and asteroids are the most incredible thing because we're going to have to build sophisticated infrastructure to go extract the gold from the asteroids. Like, that's amazing. Right? Like, gold is the perfect money. It scales with us to space. Like, yeah, let's go into space and get some gold. That's a great reason to go to space. You can just mine more gold? Yeah. You know what happens when you mine gold? You're buying mining equipment, and mining equipment is buying engines, and engines are buying fuel, and you're stimulating the economy. Instead, it's 5 people with an Epson printer hitting print a bunch of times. I don't want to sound like one of them libertarian assholes, because, you know, you don't have to be a libertarian to realize that, like, you can't let the government print the money. It's not just the government who prints the money, it's all the VCs too. Where do you think the VCs get their money? The VCs get the money from LPs. Who are LPs? LPs are just pension funds. Where do pension funds get the money? They are the government. It's all the same shit, right? There's 2 sides of the thing. There's the people who print the money and the people who work for the money. And if you're not printing the money, you're a clown. And everybody who works for the money needs to get some pitchforks together. You know what? We don't even need pitchforks. We don't even need pitchforks. We just need to stop accepting their printed money as legitimate money. It's not. It's completely fake. It's a bunch of cronies with a printer. Sure, you can take your fake tax dollars and your fake money. That's fine. But when it comes to anything real, I'm going to make a coffee shop and we're only going to accept gold. All right? But we all need to stand strong and we all need to do this together because that's the only way this stuff gets fixed. Otherwise, this will never be fixed, and they will continue, the scams will continue, the beatings will continue until the money improves. Most money printing comes from the private banks. Well, if the banks were private, this would be fine, because banks can fractional reserve all they want. But people need to stop thinking of banks as a secure place to hold their money, and you better keep your gold under your mattress defended by a unitree with an AK-47. No, I don't want bitcoins, okay? They're worse than, they're dollar level. Crypto is dollar tier. But it's algorithmic. The algorithm says they can't make it. They do. Remember that time Ethereum rug pulled everybody and switched their proof of work coin to proof of stake? Right? There is no, sure, Bitcoin's a little bit lindy, right? If Bitcoin's been around for 200 years and nobody's changed the 21 million, I'd believe it a little bit more, right? But again, that's younger than our Constitution, right? You want to talk about how lindy something is, it really matters in money. But Bitcoin's been around so long. It's been around less time than nvidia, okay? Nvidia shares, Apple shares are more hard money than Bitcoin. Is to have no owner, yeah, but like, you know what has no owner? Gold. Or gold is going to happen. Oh, gold is going to happen, right? Gold happens when everybody loses faith in all the fake money. Why is it doing so well? Another question to ask is, why is gold doing so poorly, right? The problem with gold, and the reason gold doesn't do the same shit that crypto does, is you don't often get, where they put a lot of work into avoiding hype cycles, right? No one thinks gold is going to 2x in the next year. Right? You don't get these fake hype cycles which drive the crypto market. Other minerals have similar properties. Which one? No. Growing economies don't need the most liquid assets. This is completely fake. This is you've fallen for a scam. You've fallen for a scam where it's like, well, we're just going to print more money, so now we have more liquidity. No. This is not how it works, right? What you just did there, so you have a map in the territory, right? What you just did there was you had a map, and you're looking at the map, and you're like, oh shit, we're going to have to walk across this mountain. And then, like, you know, the guy next to you is like, I got an idea. And he pulls out an eraser, and he erases the mountain from the map. oh yeah, oh that's fixed, oh good job, oh yeah, that's gonna be so much easier now. No, all you did was change the map. You didn't change the territory. He folds it, right? He folds the map. He folds over the little hill. All right, if we're getting to 1971, it might be the end of the stream. We did some good Tenstorrent stuff. We struggled with this stupid crap. No, we need like a good Python. 1971 means the end of the stream. You guys, like, it is not going to get better. It is not going to get better until here. What's the quote? It's at the end. I don't believe we shall ever have good money again before we take the thing out of the hands of the government. That is, we can't take it violently out of the hands of government. All we can do it is by some sly roundabout way introduce something they can't stop. Gold. It says something when I run clang to Pi. Oh, do I have to put it in? Oh, do I have to like put it in C++ mode or something? Oh. Oh, Clang C library are different. Oh, okay, okay. This might be we have Jammy? I don't know. Yeah, instead of banning Bitcoin, they approved the ETF. Exactly. Exactly. Okay, we can have Clang 12. Are we happy with Clang 12? We can't have Clang 14. That's not allowed. I might have to tell it it's C++. This might actually be a real thing. Still getting that same bug, but now it's that. I don't think this matters. We can try it. No, that's not the problem. But there might be a flag for inclined to Pi for. Maybe I did like, it's like -x CPP or something. CPP. Error parsing translation unit. Alright, we have to go back to subscribers only if we want to do anything. But I agree that we are... The mistake was literacy, right? The minute you give people literacy, you can brainwash them. And if, like, most of the country was illiterate, they would understand. But
but the money is, you just print the paper. The money is made of paper. You print the, oh, no, you don't understand. You see, there's an organization and it's separate from the government. And then there's this thing called blockchain technology. Like it's, no. Why is the money not a coin made of gold? But where are you going to store your gold? Yeah, this is not a real problem, okay? People have been making it work for thousands of years. But today we have more money than ever. No, we don't. Like we don't have, no. Oh. For thousands of years, everybody understood this. Everybody understood that you can't have one asshole making the money out of paper. Or, God forbid, fake internet money made out of cryptography. Wait, gold wasn't brainwashing. Gold could buy you land and people. I mean, yeah, land and people have always had value, but like, those things still have value today. Like, land has value. How is this code even supposed to work? Okay, those structures and functions, that's looking pretty good. Right, we had that old thing which was getting on PCI devices. We had the can TTL do this? What can it do? All right, maybe we should be thinking about this in a different way. Maybe we should be going even lower level than this. Like, what are these metal things doing? Why aren't we just calling Clang to do the risk building? We should be able to do running from tt-lib, I believe. Let's see what's in here. Okay, where is tt-lib? We want this to be free of all the smooth metal. Yo, should we just be using strace? What's this actually doing? Let's instead of going higher, we should go lower. When they go low, when they go high, you go low. All right, so these things are actually being built. What are these things? Oh look, these are the DRAM knocks. Oh, that's cool. The minute VCs invest in it, you know it's a scam.
And VCs have invested heavily in blockchain technology. Notice how they haven't invested in gold. Like imagine a VC funded like, you know, it's like a little bag that you keep on your chest where you keep your gold. Right? You don't see them making that, but oh, we invested in a crypto wallet. See, that's how you know it's a scam. Much simplified element-wise binary at the top here. Oh yeah, but I mean this is just, this just has wrappers around it. Oh wait, what? I don't understand. What do these things do? Well, this is in the kernel. Acquire 8 tile registers. Oh, this is the compute kernel. Okay. I mean, we're not even close to this yet. We're still struggling. I'm going to try to figure out where the RISC compilers are actually being called to figure out if we can tap into it at that layer, right? Because like we really don't want to use, we want to use as little as possible and get to yeah, I mean, this stuff's probably fine, and there's probably like a whole, like a runtime build environment that we can extract from this that includes this stuff, and it's probably cool. But I'm just talking about all like the outer device layer stuff. It asks money from the bank. Well, the bank can give them gold, right? Like, I just want you to think about fractional reserve banking with gold for a minute, right? Like, I bring 10 pounds of gold to the bank, right? See, with paper money and fake databases, this all seems kind of okay. But when you actually get down to what fractional reserve banking is, it means that they're loaning out 9 of your gold pounds to other people, and assuming there's not going to be a rush on the bank where everybody comes and asks for their pounds of gold back at once, right? Suddenly banks don't seem like the most genius idea anymore, right? But when the money's all fugazi, oh yeah, well you see, you know, the bank has deposits to, no, like I want you to think about this in terms of literal pounds of gold, right? Like when I go knock on the Bank of America door, if I'm depositing 10 pounds of gold, right, like where are they putting my 10 pounds of gold? Think about that, right? Just imagine daycare that loans out 90% of your child, right? That doesn't sound like a good idea. Why do you think fractional reserve banking is a good idea? One day everyone will come back for after their children back. Don't worry. We're lending out your gold. But when you come for your gold, we'll give it back to you. Well, how are you going to do that if you're lending it out? Well, you see, we're going to take some of other people's gold and give it to you. We're putting it in a big gold vat. But what if everybody comes and asks for their gold? Oh, well, like that almost like never happens. Also, we have like FDIC insurance and the gold printer will bail everybody out. Oh, good thing there's a gold printer. What does it call into? So once we go very, very deep down through tons of crap, we found the call to system. See, this is the problem with all these crap layers of abstraction. Your thing is forking multiple times to build this code. Ah! Ah! Oh, here we go. tt-metal backend dump run command. Let's see. That seems cool. Alright, so where's my... That runs a kernel. Alright, let's try that. Whoa, that's a lot of system commands. No wonder it's so slow. These numbers. Whoa, what's a command queue producer? How come I didn't know about command queue producers? Where does that guy live? Well, I looked at all the system commands it was running. And there's a ton of them. Oh, you know what? Well, my kernel is very complicated because I'm doing... Okay, we have a lot more to do before we try to run multiple kernels. We still don't really understand how one kernel runs. So let's get rid of dprint. Does that have less commands? Tons of commands. And I don't think there's a cache. Oh, well, no. That only is happening because I'm calling the dprint. I'm passing in the magic dprint cores. That did not change the insane number of system commands that are run. Wow. Good thing this computer's fast. Look at all this stuff. We rebuild risk common every time? Ooh, a dispatcher kernel. Oh, that's cool. We need to expose that. Yeah, okay. We have not gotten to nearly the lowest levels yet, and I apologize to everybody for trying to jump ahead and write Python, because we're nowhere near there yet. We do not understand how this thing works yet. We didn't even know it had a dispatcher kernel. Okay. Let's go lower. What's brisk K? What? No. If you don't believe in gold, you're being scammed, okay? That's all I'm saying. How is it for thousands of years everybody used this, but somehow in 1971 we became enlightened and realized we didn't need that anymore? And then everyone, you know, just really ponder that question. I mean, there's only two answers to the question. One is, yeah, bombarding lead with neutrons will produce gold. That's incredible. And if we could find a cheap way to bombard lead with neutrons, that would be great. But we haven't. Right? Gold has stayed this incredibly good. I mean, gold is still scarce, right? Gold is still scarce. It's still, if you could figure out how to turn lead into gold today, you could still make a lot of money. What I'm saying to you is one of two things is true, and you should very carefully think about which one you believe. One, we discovered something new about the world in 1971, and suddenly money didn't need to be backed by gold anymore, and everything's okay. Or two, you're getting massively scammed. Now, I'll note that every single time in history they've tried paper money before, and it's not a brilliant idea. It's not like it took some like next generation scientists to be like, well, instead of gold, which is hard to find, what if we just printed our logo on a piece of paper and told them it was money, right? Trust me, the Romans had that idea too. Physical asset shortage, yes. Why is there a shortage? Right? You can't just again, like, yes, you know what sucks? When you have to walk over a mountain. Like, oh, we're going there and we have to traverse over that mountain. The solution is not to fold the map in half and be like, look, the mountain's gone, right? That doesn't fix it. That just hides the problem. Right, sure, maybe you'll march along for another 10 miles and be like, there's no mountains here. I have this good quality map. It aggravates me so much. It aggravates me so much that like you're arguing with me. Like that you're not like, you either believe thing one or thing two. You either believe that like they discovered something new in 1970, or you're getting massively scammed. And I know the latter is just like hard for you to believe. Like I know no one wants to believe that, right? No one wants to believe. Everyone wants to believe things are okay. But like they're just not. And they won't be until like what we call money is real again. No, it's not like a little scam, right? It's not like a little scam. The entire basis of the entire world economy is fake. It's not like a little scam. It's not like, oh, we're selling some people like some homeopathic medicine, right? That's like a little scam, right? That's like a little small tier scam. Yeah, we're selling them water, and we told them about the water memory effect, and we diluted rose petals 10,000 billion times, and they put it in their ear, and it's actually just water, but they get better because of the immune system, right? Like that's a little scam. The entire global monetary system is completely fake. That's the biggest scam of them all. Like the whole substrate is fake. The whole substrate for all other scams are fake. This is the Mac Daddy of scams. Is there more debugging info I can enable somehow? That would be interesting. Like, somehow I'm pushing... There has to be something that's like loading these things into memory. I guess it could be the loaders. But there's some like DMA engine that I'm pushing over PCIe. Actually, let's take a look at the kernel driver. I should have it, right? Because I built it. KMD, here we go. Good. It's a very simple kernel driver. The character device should be in dev, I guess. Where did I actually open that device? Search for dev. There we go. Dev Tenstorrent. Do I have a dev Tenstorrent? Oh, I have a dev Tenstorrent. Great. Command queues are in pin huge pages in system memory. Dispatch kernel running a device pulls binaries. Runtime args from CQ, PCIe. All right, cool. Yeah, so let's take a look at how this is actually working. Something's opening dev Tenstorrent here in UMD. Oh, so yeah, it's this UMD thing. Yeah. So UMD is the actual I wish it told me what UMD was. Ooh, emulation. What's this? Zebu EP1 emulator? What is this? Cool. I didn't know about these things. Yeah. So that's what I'm trying to do. I'm saying, like, if I can get into the... Okay, UMD is user mode driver. That makes sense. So if I get into this, maybe there's, like, prints. It's all in C++. Goddamn C++. Wow, so much stuff. So much stuff. Where are these functions implemented? Oh, here we go. TT emulation device. It's TT silicon driver. Read from device right here. Okay, so these are the things that are actually controlling the chip. TT metal logger level debug. Let's go. Oh, cool. Okay, so that shows the... good. All right, I like this. That's a complicated one. That's my simple one. It includes a big rant about gold. That's because I'm getting tired. It's almost nap time. Cool. Oh yeah, so okay, it's exactly this stuff. So NQ write buffer, NQ program. I don't know why we call finish twice. Oh, I guess we call finish twice because I did the other one async. But then why isn't that printing? I would expect this NQ read buffer to print something. The finish must just be in there because that's probably the only way the sync stuff works. I don't know why those are called always. Always. So the trisks are the kernel processors. Wait. Why is... Oh, is hex actually hex? It's actually hex. Oh no, XXD there. What? It's actually in hex format. Yeah, okay, so that's not a binary for some reason. So I was gonna see like exactly which one is which. But compute kernel runs on Trisk, runs on these guys. So that's these. Yeah, so these are building the compute kernels. Now that's a brisk. So we have brisks and trisks. Where are my brisks? This doesn't have brisks. Oh, probably because that's not the name of the kernel. Yeah, the kernel is reader binary, so this is going to have a brisk. That has an NC. Well, okay, no, there's a brisk, but it's actually, this is an NC risk. If I get the writer unary, it'll have a brisk. Yes, it has a brisk. Okay, that makes sense. Okay, so we have an NC risk, we have trisk 012, and we have a brisk. Let's take some notes. Grayskull has 120 cores. It's not Python, stop, it's not Python, it's text. There's that matmul example you sent me that explains what the three are. Yeah, okay, so there's unpack, math, and pack. Respectively? There's brisk, and there's also NC risk. Each core has 5 RISC-V processors. You know, it's interesting that you chose to, like, there's 5, but you chose to only expose 3 of them, and I wonder why. But in theory, you could expose all 5. Oh, so I actually know, yeah, writer unary is brisk, so this is, 0, no, I understand they're all exposed, but what I'm saying is you, at that API level, you wrote your compute to look like this, where these are actually running on 3 different kernels, and the read and writes are completely separate compiled kernels from the thing. Yeah. I kind of like, that seems like a somewhat arbitrary distinction to me. I mean, there's probably a reason for it, but it's read kernel, it's write kernel. We can give some names to these things. I mean, just as an example, I imagine these are pretty universal. It was a bit confusing. Okay, yeah. So you just wrap it with things, wrap it with these macros. Okay. So the driver has 2 parts, KMD and UMD, user mode driver. Debug with yeah, not much to be gained by explicitly controlling 3, sure. Each core has 1 MB of L1. And this can be used for either circular buffer or long standing L1. NQ write buffer. I don't understand why there's not an NQ read buffer here. I think there should be. So like in this program here, I'm doing this NQ read buffer, but I don't know why that's not yeah, why isn't it printing with debug? I want to see like everything that can go kind of on the command queue. Is this it? Let me find the command queue manager. Ethernet crap. Let's trace down the command queue creation. Oh, well that's interesting. So the command queues are pre-initialized. Thank you for the bits. So there's hardware command queues and software command queues. I don't. Why? Is this like fake? Like they do like fake queuing? I hate this stuff. Like AMD does this too, and like we ripped it all out, and we had to find where the real command queue was. I mean, the key thing you want to be able to do to make neural networks fast with command queues is you want to be able to reuse the same command queue. Yeah, hardware command queue is the real queue. Okay. So that's what I really want to push to. Here, oh, here's the command queue dispatcher. Okay. Okay, cool. So let's find where this actually like. Yeah, okay, great. So it's these device commands that actually. I mean, I like looking at what the actual format of the command queue is. So we have some packetized thing called a device command, and I imagine there's some serializer for it. Yeah. We set some crap. Command header, and then we have whatever. It's a lot of stuff. Yeah, okay, so we put these command queues. Then I imagine there's something which dumps the software command queue, the hardware command queue. But that's actually really cool. You're telling me that the command queue parser is just a kernel. Oh, is that what that thing on the end was? That I wasn't sure what it was? The thing on the end in well, yeah, it's a kernel, but is that what that special, is that what that arc thing is? Like, is arc your oh, no. So it's just like a normal kernel that runs on a core? Oh, you take a row of 10.6 cores. Okay. So, in other words, I don't actually get... I lose 10. You're on dispatch kernels command keys. Okay, cool. Well, that's cool. At least it's not like the stupid MES on the AMD GPU. Like, this is the stuff I'm trying to get AMD to open source. Because I'm very interested in how all the scheduling works. Because scheduling is the key to make neural networks great. Yeah, no, this is awesome. You guys have really, yeah, open sourced everything I care about. Yeah, I mean, I don't care if the firmware's open source or whatever, like secret bring up. That stuff's not important as long as all the scheduler is open source. Because there's so much that can be done there. Oh, okay, so these are the kernels. I see. How stuff works. Oh, okay, so this is like a special, this is like shared memory. And it's just loading those on. Let me see if I can find what actually I mean, there's got to be something. I wonder if I see it with the dispatch, right? Because it's got to be. What is all that stuff? LL runtime? Where's all these? That one's reading the CQ and huge page. I'm trying to figure out where it's actually, like, where's it dispatching them? Firmware init complete. It's got to be these then. But it's running on all of them, not just... It's running some LL runtime on everything. In fact, shouldn't I be able to, unless it's pre-compiled... No, here it is. Wait, that's like really close. Yeah, right here. Oh, so here you go. You're in row 11, and you're dispatching it here. Oh, producer knock. There's super lean firmware running on every BRISC. Oh, but look, okay, I see. Your producer and consumer are just. I see it. You took row 11. But your producer and your consumer are just on 7 and 1. Whoa. That just accepts kernels from the dispatcher, but then there's this extra command queue thing that... Okay, cool, I understand. Yeah, I think with so many of these things, like, you don't need all these layers of abstraction. What's wrong with just directly dispatching from the
Oh, I guess I kind of understand. So you don't want to have to manage the. You don't have to manage that from the host. You don't have to manage kernel dispatch from the host. So you just do it on 2 of the cores. I mean, I imagine the 10 are reserved, but it's just on 2 of them. And you recompile them every time. Don't recompile them every time. Use a cache. These are like the kind of things you just get for free in the tinygrad, like caching around all this build stuff, and it's all free. I mean, yeah, it can be captured into a trace, sure. But the dispatch on the Ethernet cores, yeah. Again, sounds like premature optimization. I wouldn't worry about any of that stuff. I would just say, like, what's the so much complexity here. I mean, this is the downside of, like, yeah, I know, like I know it's tempting to go to these like big scale things, but like again, I tried to multiply. I mean, you saw my demo, and I don't know what I did wrong, but like I tried to put the matrix multiply in a loop, and it crashed. Like, I think that there's a problem here. Like, Groq is the worst about it, right? Like, I'm sure Grok's way behind you guys. Groq showed off that one Mixtel demo, and they're very happy with it, but that doesn't mean you have an accelerator you can sell for anything. I think that, like, I mean, the hardware is pretty incredible that it's so flexible. I mean, maybe GPUs are this flexible and I just don't know enough about them. I wonder how much, probably not. I mean, GPUs weren't done with a very clean sheet design. It's probably just hacks on top of hacks. Like, is there a way in a GPU, if I had like firmware control, that I can dispatch different kernels to the different compute units? I'm so interested to read AMD's. They're going to open source it. They'll open source it, the MES. But I think I even want to go below the MES. I want their command Q parser, and that one they say is harder, so we'll see. It's also all signed. There's nothing looks signed on this. I don't think it's trade secrets. Things are going well with AMD, yeah. I mean, you could work forever on this software. There is like no limitations almost to how good you could make it. This chip has so much flexibility. I mean, it's a 600 core RISC-V chip. And I can run arbitrary things on all the cores. It's not the HDCP problem.
What is this firmware? ncrisc.cc? Well, I imagine that's for the NC risk. Probably one called Brisk as well. Oh, yes. Are there separate ones for each of the, no, there's just one Trisk. This is the, yeah, they spin and wait for the, makes sense. Okay, I think there's one more thing I want to understand, and then we'll call the stream. So I want to understand kind of what the memory, what the math engine looks like. Like what the I think I get everything except for now what actually the math looks like. So let's make a section called math, and let's look at the teraflop numbers and figure out how they're actually achieved. So somehow we're getting 7600 G flops per core. It's 32 by 32, but so you're saying it's a Mac? Okay, so 200. Yeah. Okay, so then to do that out, we have you're running at. What? No. You're only running at 300 and... No, I know the megahertz. It's running at 1300 megahertz. So you're saying each core... So this should be 120 times 248 times that many megaflops, right? That would be a 319 teraflop chip. Oh, that's mollads in something small. These are the block-based 8-bit floating points. In block 8, okay, so that's block 8, I see. So I don't know why I'm only getting 320 teraflops there. 30 times 32 is 128, so it's 32 by 32 Mac. I don't care if it takes 32 cycles, it's pipelined. Yeah, let's take a look. Yeah, thanks for helping me. I think it's a good, it's a fun way to get some documentation. Wait, for regular bfloat 16, I can do that many? No, this looks like a factor of 3. Oh, docs are wrong. Okay. i5 mode consumes all the mantissa but one LSP. Oh, okay. I don't know why it's easier, but probably. I don't know. This gets into stuff I don't know about making hardware. Yeah, I don't know how math's actually fast. I don't know what a lot of these things are in practice. But that gets down to the lowest levels I know. Maybe someday I'll go lower. But yeah, so it's just, I mean, it's instructions. And this is for wormhole. If we want the Grayskull 1, common, yeah, C kernel. Yeah. C kernel ops. I mean, there's a whole rabbit hole to go down here about how these dispatches, how this stuff works, like how unpack. And it's putting them in. Let's just read the. Yeah. I see the custom instructions. More what I'm thinking is like, so these must have like weird registers that are defined somewhere. GPR is general purpose register. What's face dimension? Okay, so it's a 32 by 32 Mac. It's notably not a tensor core. Like you're not doing a multiply with one instruction. I don't actually know. Like, look, I know the API for the GPU tensor cores. I haven't actually thought about how a GPU gets built. But so it's a 32 by 32 Mac, and the neighbors can combine for BF16. Can it do float 32 or just BF16? And it accumulates in BF16 also? Is that okay? Or does he accumulate in something bigger? Well, I don't care about the multiply. Can I BF16 accumulate in float 32, or does BF16 accumulate in? Bfloat 16 accumulator. Does that work for training? We have debates about this at work. Oh, whatever that means. I'll write it down. What's it do? Oh, in Grayskull, in wormhole. Okay, I see. Yeah. But the FP32 accumulate is free. Yeah, I see. Yeah, it's very hard to train. You need really to accumulate in float 32. You never need a float 32 multiply. Like float 32 multiply is kind of useless and expensive. With that squared shit. I mean, yeah. You know the NVIDIA scam? For everyone who doesn't know the NVIDIA scam. So, where is it? Here is here's a 4090. So the RTX 4090 has a peak FP16 with FP16 accumulate 330 teraflops. But then if you accumulate an FP32, you only get 165 teraflops. This is a total scam, and it's just done by software. They blew an eFuse on the dispatcher to not let it accumulate and float 32 fast, so you can't use the thing for training. Which is just, it's just offensive. Like, there's no reason. Look, here it is doing FP32 accumulate in 330. But yeah, this is complete. This is a complete scam. And you know, because the same. Actually, that's wrong. That's wrong, because if you buy the expensive chip, which is the same die, it doesn't have the eFuse blown. And like I went into the driver, I was really hoping it was just something in the driver and the compiler. I looked into the driver and it's an eFuse. So, you know. Thanks, NVIDIA. Thank you, NVIDIA, for giving other people a chance to catch up, actually. I mean, if this really was the number of 4090s, if 4090s were that, we'd have to use them for the tinybox. But fortunately, 4090s are that, and that's not actually so far off. AMD doesn't do either of these things. So there's two big features that NVIDIA blocks on their 4090, and one is this, and the other is peer-to-peer transfers between the cards over PCIe. They're complete. The high-end cards can do it. These cards can't. I mean, you know, I'm too old for jailbreaking. All I see when I see that is the way that you do this is you just need to make NVIDIA like feel the need to compete. You need to put pressure on them. TinyCorp will know they're succeeding if NVIDIA stops doing that in their future GPUs, because they literally have your training power of your 4090s. You should be upset and offended. Cool. I think that's today's stream. I think I'm gonna take a nap. Alex and I got a nice sushi dinner tonight. Yeah. Thanks to Tenstorrent, guys, for helping me understand this. I'll push my documentation. My general advice is this thing could be amazing, but the software is going to be a huge journey. You know, we're in luck. GPUs have done a lot of this stuff for you. Like have a lot of sort of. It's not that they've done a lot of it for you. It's that the GPU, like the CUDA style of programming, has been around now for 15 years. So people kind of understand how to do it. Whereas when you're given a chip with this much flexibility, we have no idea what the correct abstractions look like. I would really avoid making things. I'm glad I see that it's using TVM. I mean, TVM is a great choice. I think there's a few things that TVM exposes that they shouldn't. Like TVM, you have to make a choice when you're writing something like this, whether you want to allow like CUDNN style things. CUDNN style things help you in the short term, but hurt you massively in the long term. Because you're not going to be able to do kernel fusions, you're not going to be able to do searches, you're not architecture portable. The only thing in tinygrad that's not architecture portable is that tensor core definition. And it's not architecture portable because that's literally, I'm describing the hardware, right? If you want to do something that's not architecture portable, it better completely describe physical metal transistors on your chip. Whereas a lot of these things, even things like command queues don't, right? Like command queues are abstractions that you've put pretty low level in your software that don't have to be. I think that what you want to do is, really think about write the most generic software you possibly can that also works on GPUs. You can imagine the same abstraction being used for GPUs. My theory with tinygrad is we are not succeeding until we have replaced the entire user spaces of CUDA and Rocket. It is only after we've done that that we can consider making our own hardware. Because yeah, the software complexity is just insane. And a lot of times what you end up doing when you don't understand the software you're writing, you end up making the hardware too generic. And that generic nature of the hardware is burning power, burning transistors that could be used for faster shit. But it's pretty cool if you're really getting those kind of teraflop numbers from a 12 nanometer chip. I don't know, what's the die size? Oh, it's 600. Oh, okay. I mean, that's pretty big. Yeah, still, those numbers are, well, you're at a 3090. With that, of course, there's the RAM bandwidth issue. I understand why. It's DDR4. I mean, that's something that has to. Yeah, that kills you. I think it's higher than that though, right? I thought it was like 200. I mean, yeah, that makes training basically like impossible until we all move to the new paradigm of training, and that gets even further down this crazy rabbit hole of software, which is like the current training. I mean, look. The current training methodologies are insane. If you told me 10 years ago, when I was first seeing AlexNet, that like, Lux, hello, welcome new people. We were just getting off stream, but we'll do a little recap for the raid, and then we'll end today's stream. Yeah, what we did today was we played with the Tenstorrent E150. You can purchase these guys at Tenstorrent's website. Again, if you're planning on purchasing it to do something, doing things. But if you want to play with really an incredible piece of hardware, that's pretty unique. And look, I would not endorse this hardware at all if it was not open source. So not only is this hardware quite unique and cool, it exposes everything to you. You can go through and you can see. So when you have like a GPU, right? Like a GPU has a programming model. AMD is a lot more open source than NVIDIA, but when you have an NVIDIA GPU, you're basically given the CUDA programming model. And if you are not okay with the CUDA programming model, well, NVIDIA tells you, get bent. But AMD lets you go to lower level stuff, and then Tenstorrent lets you go to an even lower level than that. So in terms of like open sourceness, this is more open source than AMD. You can see things that AMD, I mean, I'm pushing AMD. If you follow me on Twitter, I'm pushing AMD to open source stuff. But well, good. Oh, this is another thing that I can mention to them. I'm like, Tenstorrent's going to be you guys, Tenstorrent open sourced their command key processor. You guys didn't do that. So yeah, I don't really know how flexible modern GPUs are. In a lot of ways, modern GPUs do look similar to the Tenstorrent things. So what the Tenstorrent thing is, if you guys are interested, it's here. This is a pretty good picture. Actually, I'll just find that guide.md. Here it is. So this is basically what the Tenstorrent chip looks like. Make that, don't move that. Make that a little smaller. So this is pretty much what that chip looks like. And each one of these workers is 5 RISC-V processors in a tiny little chip. So this is what happens when you zoom in. They call it a 10-6 core. They have two of them for data movement. I think there's something special about them, and then 3 of them for compute. The compute, you can imagine one guy with a shovel over here, one guy typing in the middle on his calculator, and another guy with a shovel over here. That's how the compute goes. You can imagine the data movement guys are operating something that looks like bulldozers. Right? One guy's coming over here dumping dirt for the shovel man, driving the bulldozer back and forth over here. One guy's coming over here. He's taking away that dirt, moving it on. back to memory. So yeah, that's kind of what that looks like. What's here? Yeah, so this is basically what I was saying. Bulldozer's here, shovelman, bulldozer. Cool model that is all completely exposed. So if you want to play with new, unique computing hardware, yeah, come check out this card. But yeah, there's a long journey to building a useful neural net stack on top of this, and I think a lot of the stuff is jumping the shark. I think companies have this very unfortunate nature of deciding, well, we need to get started on that problem today. So they'll take a problem and they'll try so hard to subdivide that problem into multiple tasks so they can put multiple people on it. This is why software looks bad today. So much software looks bad because they're trying to parallelize things that are fundamentally not parallelizable. What you do is you have a 100-person software team. Guess what happens? Your software is going to have 100 pieces. It doesn't matter how complex the software is. Your software could literally be like, I press a button and a Skittle comes out of a Skittle dispenser. But if you had 100 people, well, that software is going to have 100 parts. Your software will always reflect your organization. So it's unfortunate that like this is kind of what a lot of this stuff looks like. They've built this ecosystem. They have 2 different looking docs websites. You don't want, you know, if you have a software team of 100 people and you have 10 geniuses and 90 mediocre people, your team is much stronger without the 90. And instead of focusing on trying to do everything in parallel, focus on building up slowly, serially, exactly what you need. Yeah, and I think that would end up with a much better thing at the end of the day. But yeah, so what did I actually do this stream? I wrote up some basic stuff to run a simple kernel that doesn't really do anything, but at least all the pieces are there. A junk Python API I didn't finish, using Tenstorrent's Python API, but I'm not really sure what it can do unless I use ttnn, which I couldn't get compiled. There is this high-level demo here. We'll throw that guy in there too. Which uses PyTorch, but don't put this output in a loop. Don't put it in a loop. If you put it in a loop, you're going to have a bad time. Using py-buda. But like this is the kind of stuff that people exactly don't want to use, right? Like the best thing is compatible. The second best thing is completely incompatible and different. The worst thing is, well, it's like kind of compatible. Kind of compatible is the worst. Look at Python 3. So yeah. Oh, and we should I forgot to normally, yeah, I should be better about that. When people raid, I should let non-subscribers talk so you guys can all talk. We're in the talking part of the stream now. We're going to do about 5 minutes of talking, actually, because I'm tired. It's nap time. I've been on that biphasic. You know, there's 2 sleep schedules that have ever worked in human history. It's monophasic and biphasic. So I've been on like a biphasic sleep schedule. I got like 6 hours of core sleep and then an hour and a half nap. So it's nap time. Skibbity. Please stream more often. Well, I had something special for today's stream. Today we learned about the Tenstorrent cards. Yeah. It was good. It was good having them in here to explain stuff. Yeah, TinyCorp is a lot of work right now, but I really think you guys should try to port this to tinygrad, and then focus on it lets you focus on what the real problems are. A common thing you'll see about No, he didn't. You can't actually sleep 20 minutes 6 times a day. That's myth busted, bros. A common thing you'll see is again, it's people it's the humanoid robots are a perfect example of this. Humanoid robots are complete cargo cults. So for those of you that don't know the story of the cargo cult, let's see. Let's just bring up a picture. So this, it's from Business Insider. But so there was an island in like the South Pacific where the U.S. was coming and using it as a base during World War II. And the U.S. would bring planes, and these planes would have MREs in them. And, you know, the indigenous people there were like, wow, this stuff's amazing. But then the war stopped and the planes stopped coming, and they were upset about this. So, you know, they built some planes to try to make the planes come back. Yeah, well, it turns out that that doesn't bring planes back, right? It kind of looks like a plane, but it doesn't bring planes back. So, you know, the humanoid robots are the exact same thing. People have things that have the brain of a bird, but they build a thing that looks like a person. They think that somehow that's going to imbue it with personhood, which in reality, you know, if you can't make the comma body work, if you can't make the comma body do everything, like if you can't make the comma body into like the world's best security guard, stop trying to build a humanoid robot. Find out something about cargo cult. Yeah, learning how not to fool yourself. I think I've actually read this. Yeah. We'll read this. Maybe I never read this. Excellent school. Or at least, I don't know. I still thought it was cool, even though I hear it's like corporatized and terrible now. Yeah. They follow all the apparent precepts and forms of scientific investigation, but they're missing something essential because the planes don't land. I think there's a ton of this sort of thinking out there today. Trying to explain to them why building a plane out of sticks isn't going to be a plane, right? Yeah, right. Like, don't fool yourself. People fool themselves all the time. People also, look, I'm guilty of this with tinygrad. Everyone's guilty of this, right? Like your software, there's software that other people use, and there's software that you can use, right? There's software that a few people can use. There's software that a few people are willing to put up with. It is so incredibly hard to get software over this usefulness point that people will put up with anything in order to use it. First principle is you must not fool yourself, and you are the easiest person to fool. This is exactly how we started the stream, and this is how we'll end the stream. If you lie to other people, you lie to yourself, right? Like, you start by lying to yourself, and then it manifests as lying to other people. So the men in charge of programs at NAL are so anxious for new results. In order to get more money to keep the thing going for public relations purposes, they are destroying possibly the value of the experiments themselves. And so the men in charge of VC firms are so anxious for new technology in order to get more money to keep the thing going for public relations purposes, they are destroying possibly the possibility for technology itself. What's the conclusion of Tenstorrent? The open sourcing is very smart. You know, this is the most open of any of the accelerators you can buy. I think that's true. I think that's true. I think, I mean, you can look at the Google Coral. I did a whole bunch of reverse engineering on that. Closed, Apple NPU, lockdown. If Tenstorrent manages to keep this level of open source, start being really honest about like what parts of the stack they should work on and what parts of the stack they shouldn't work on, don't give bounties for models. Like I understand the bounties for models thing is like tempting. I understand tinygrad does it. In fact, I think the model bounties are some of the worst ones. But yeah, don't like that's not your strength. Your strength is not that we can run a language model at X number of tokens per second. Give that to the Olama people. Give that to the CPU. Give that to the. You know what? We'll end the stream with this thing. Where's the TRUFFLE? TRUFFLE AI. I thought it was an overpriced scam, but it's actually less of an overpriced scam than I first thought. Oh, I don't know. Oh, maybe they don't actually have any software at all. But regardless, it doesn't seem like if they really have an orin with wait, how do you know it has 64 gigs of RAM? Who fooled me into saying it has 64 gigs of RAM? Does it have 64 gigs of RAM? I don't know. 60 gigs of RAM. Okay, that's RAM. Regardless, like the truffle one, how many truffles in a tiny box? A ton. Truffle, if you're just going, their headlining thing that they're talking about is 200 gigabytes per second. The tiny box has 5,700 gigabytes per second. So by that ratio, there's about 30 truffles in a tiny box. And there's only 13 truffle. You can buy 13 truffles for the price of one tiny box. So, you know, it does work. How would you use an LLM at a high speed without using Groq? Dude, you can build that demo on NVIDIA, just nobody gives a shit. You can build Groq's exact demo. You give me an 8H100 machine a month, and you know what? How about this? If someone buys me an 8H100 machine, I will build you that exact same Mixtral demo if you let me keep the machine when we're done. Okay? That's my challenge to anyone about that stupid Groq demo. Like, oh, it's 500 tokens per second. You give me an 8H100, like an SXM 8H100 machine, like a $400,000 machine, cheaper than the Groq. I will build you that exact same demo if you let me keep the machine when we're done. So yeah, that's a challenge to no, you will work, but you won't be able to build the demo. I can actually build the demo. I know exactly how to do it. It'll take me a little more than a Twitch. It will probably take me a month. But yeah, I'd work for a month for 400K. Sure, why not? And I'd learn a lot of cool things about GPUs. So if someone, hey NVIDIA, if you want to take me up on that, send me an 8H100 machine and I'll build you that Groq demo. I'll build you something faster than that Groq demo, or you can come take the machine back from me. I do know you. You're not even a subscriber, bro. Yeah, if NVIDIA would like, yeah, 8H100 SXM. Give me one of these machines, and I will build you that stupid Groq Mixtral demo. Yeah, one of them. That looks nice. Wow, it's not even that unreasonably priced. It's only Why am I skeptic about Groq? Well, if someone wants to give me one of these, I'll build you that demo because you can build that demo on NVIDIA just as easily. In fact, I might even be able to build a demo on a single, maybe not a single H100. But I'm not going to spend my own money on this. I'm not giving NVIDIA money. It's just 90% gross margins. 90%. Oh, it's not that Groq's a grift. I'll tell you what happened. So, like, look, Groq, let me tell you why Tenstorrent's going to succeed and Groq's going to fail, right? What does Tenstorrent do? Tenstorrent figures out, and it's not easy. It is not easy. You can go on archive.org and you can see how long Tenstorrent has said they were going to ship the cards for and ship the open source software. It took them 2 years, but they did it. It's really hard, but you can't fool yourself to do that, right? You have to, like, here it actually is. It's open source, right? You can't take it back. With Groq, they built a single demo that looks kind of cool, but it's a demo, right? Waymo drove a blind man across Austin in a long time ago. That's a bold statement that I can do better. Buy me the computer. How about this? I'll do one better. You buy me the computer, and if I fail at it, I'll give you 10 grand in the computer back. All right, so I'll put something on the line. Yes, I know you can try Groq on Playground, but if you don't understand what's wrong with that, I can't explain it to you. 300K on the computer back. It's slower kind of. I mean, I'd do 10K in like a month. See, the problem with 300K on the computer back is like, the problem with that is not even that I don't think I can do it. It's just that some absolutely ludicrous opportunity might come up in my life, and I might just want to do that instead. Look, Xtropic again. They're early, okay? They're an early startup, but don't believe in hype. Ask yourself, what have they shipped? And even better than what have they supposedly shipped, right? Like a YouTube video is one thing, but what have they shipped that I can buy? Because once they've shipped something that you can click buy it now on, well, that's it, right? Like that's where the dollars end up, right? That's like fundamentally, I gave $800 to Tenstorrent for this card, and I never expect to see any amount of that $800 again, right? It's not an investment, it's not a scam, it's straight up. That's how consumerism works. It's like, if I buy an apple, I eat the apple, great. So I'm not saying Groq is a scam. I'm just saying their demo is not impressive, and I can replicate their demo on that machine or 10K and your machine back. I mean, look, Groq is better. Groq is the same tier as like Cerebus, right? Actually, Cerebus is actually, I think, making more revenue too, which is something else to be said. The era of 1-bit LLMs, maybe, I don't know. Is it inference in 1-bit or is it training in 1-bit? Right? The largest LLMs today are still being trained in bfloat 16. Their LPU thing is bullshit for me. It's not bullshit. It's just not competitive, right? Like Tenstorrent's card is not competitive either. You should not, if you are trying to do any sort of serious AI work, like normal straight up AI work, you should not buy Tenstorrent cards. You should buy probably H100s, maybe MI300Xs, and maybe tinyboxes. But, again, Tenstorrent also, like, I think that the, like, Groq and Google TPU architecture they don't look like the brain. Whereas the Tenstorrent thing looks a lot more like the brain. And not only does it look a lot more like the brain, it's a much more buildable kind of architecture, because like the future is, okay, so we can look at Cerebus, right? Cerebus is kind of cool. Again, I had a lot of this stuff wrong. I wrote an old blog post. I wrote an update blog post, and I've learned so much more since then. I mean, this is like what I spend all my time on now. So this is Cerebus. They're doing wafer scale. So I talked to Jim about this, and what he said was like, look, you don't actually want to do wafer scale. What you want to do is chiplets and a substrate, and completely. The problem with this kind of stuff is it's really hard to get yields. And I would guess that a lot of those wafers end up thrown away, and they're like, oh, we can route around that, but you don't know how much they can route around it. Yeah, so like what you probably want is a chiplet style architecture, and something like Tenstorrent lends itself really well to that. Because you're going to have to solve the grid communication problem at some scale. Right? You're going to have to solve the data shoveling engine at some scale. Right? So GPUs don't have 5 RISC-Vs on each compute core, but they do have SDMA engines. They usually have 2 SDMA engines, right? Which is going to, I just know that the AMD GPU has 2 SDMA engines. So you can, send data there, pull data from there at the same time. Right, that's why you need 2 engines. Whoop! What's my current go-to LLM? Claude. I paid $20 a month for Claude, right? It's better than what I can get. Why does a chip company make why is it inference only? I don't know if they're saying it's inference only. I mean, the Grayskull chip is inference only because it can't accumulate an FP32. It also has crappy memory bandwidth. I don't think that's fixed with Wormhole either. But again, these things are all fixable, like in theory. No, the open source ones are cool if you need something offline or you want to, talk about naughty things. Wormhole can do training. It has FP32, more memory bandwidth. You need a lot of memory bandwidth for training. Yeah. Wormhole and Afters for training. Yeah, no, I mean training is the place to compete. Here's another one of these people who are like, we're an inference only company. No, you can't be. The future of AI is training always. The future is not models that you train once and then don't continue to update their weights. Right? Humans aren't like this, right? The future is going to be some form of always-on training, always-on fine-tuning. It has to be. Right, and we're in some very limited space of models now that don't do this. All right, cool. It's a good note to leave the stream on. Thanks again, guys. Have a good day. Enjoy your weekend.